Yeah, hi everyone, welcome to PrepFusion. So we have completed multivariable function. We understood what is a multivariable function and some particular function also we saw, some particular graph also we saw. Then we studied about maxima, minima and differentiation. Those things we have studied. Now we were supposed to start integral calculus, right? I told in the last lecture, in the end of the last lecture, I said that we are going to start integral calculus now. But before starting integral calculus, I thought that we should deal coordinate system. So this will work as a prerequisite of integral calculus. People struggle in integral calculus because they don't understand the coordinate system in a good manner. So what we are going to study now, first we are going to study about coordinate systems. Very easy topic, very straightforward. So it will work as a prerequisite or a very important prerequisite for integral calculus. If you don't understand coordinate system, then integral calculus will become very complex. Otherwise it will be very easy. Okay. So we have studied what kind of coordinate system till this point. Till this point we have studied about a rectangular coordinate system. So there used to be x axis, there used to be y axis. Now let's just say there is some point P which is x comma y. You need to reach to this point P which is x comma y. How will you reach? From the origin you need to reach to this point which is x comma y. So someone would say that, sir, what I will do, I will cover a distance of x here. On x axis I will cover the distance of x and on y axis I will cover the distance of y and I will reach here, sir. That's it. Here I will cover the distance of x and on y axis I will cover the distance of y and I will reach here. So this was our rectangular coordinate system that we already know, and we are talking about 2D coordinate as of now. That means there are only x and y available, z is not there. Okay. Now if I want to cover this whole scenario, if I want to cover this whole plane, that means if I want to cover all the points, let's just say there is some point here, some point here, some point here. If I want to cover all these points, then what could be the value of x? X could be from minus infinity to infinity and y could also be from minus infinity to infinity, right? X can go from minus infinity to infinity and y can also go from minus infinity to infinity. Say yes or no. So this is known as your rectangular coordinate system that you already know. Now let's just say again there is some point P. This is your x-axis, this is your y-axis. I want to reach to this point P only. What someone would say? Someone would say that, sir, directly from the origin, I will directly go for a distance of r. I will directly go for a distance of r and I will reach the point P. So there was some guy who was standing at origin. Okay, there was some guy who was standing at origin and you were standing at point P. So what you told him? You told him that from the origin you come to distance r. What did you tell him? From the origin you come to distance r and you will meet me. What he did? From the origin he came to distance r. Did he meet you? No. What he did? From the origin he came at distance r. Did he meet you? No. From the origin he came distance r. Did he meet you? No. From the origin he came distance r. Did he meet you? No. That means telling only r is not enough. Telling only r is not enough. What you would say? From the origin you come to distance r making an angle of phi with positive x-axis or making an angle of theta with positive x-axis in anti-clockwise direction. You will give him two coordinates. What two coordinates you will give him? R and theta. What two coordinates you will give him? R and theta. What you will say? Making an angle of theta with positive x-axis in anti-clockwise direction, come to distance r, you will meet me. Say yes or no. So what is r? R is the distance from origin. What is r? R is the distance from origin. Distance from origin. And what is theta? Theta is the angle made with positive x axis in anti-clockwise direction. Angle made with positive x-axis in anti-clockwise direction by this position vector. It is known as position vector. This line is known as position vector. By position vector. What I am writing down? By position vector. This line is known as position vector. Is that clear to you? So two coordinates r comma theta we are giving. Now if I want to, first of all you let me know what should be the range of r such that you can cover the whole coordinate system. This whole coordinate system should be covered. So what should be the value of r? r is the distance from origin, r is the distance from origin. So r would go from minus infinity to infinity or 0 to infinity? Tell me about it. R will go from 0 to infinity and theta will go from 0 to 2 pi. And if this is the scenario, then we will cover the whole coordinate system. Just think about it. R is going from 0 to infinity, 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 because r is not having any direction. What is r? R is the distance from origin, 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 distance from origin. From origin, this is the distance. It can be in any direction. Going from 0 to infinity, distance is either 0. What is the value of r here? What is the value of r here? What is the value of r here? Here the value of r is 0. And what is the value of r here? Here the value of r is r only. What is the value of r here? Here the value of r is r by 2. Right? Are you able to understand this point? So value of r can go from 0 to infinity. And what about the value of theta? Theta can, let's just say there was some point here. There was some point here. So what you would call him? You would say that come to distance r from origin, making an angle of theta with positive x-axis. So what is this theta? This theta is greater than 180 degree, right? So theta can rotate completely in this manner. Say yes or no? So theta can go from 0 to 2 pi, that means 0 to 360 degree. Is that clear to you? I hope it is completely understandable that, sir, what is r, what is theta, and how their range is defined. Here x is going from minus infinity to infinity, y is going from minus infinity to plus infinity. That is pretty simple. It will cover the whole coordinate system. You want to cover the whole coordinate system here. So r you take from 0 to infinity and rotate it completely from 0 to 2 pi. Take it from 0 to infinity and then rotate it completely. You will cover the whole coordinate system. Take it 0 to infinity, rotate it completely. You will cover the whole coordinate system. Is that clear to you? So this range is very important. Very important this range is. Now can you find out the relation? Can you find out the relation between x, y and r and theta? All these relation can you find out? Yes sir, absolutely. Can we find out these relation? Absolutely sir. So what used to be this coordinate? This coordinate used to be y. And what used to be this coordinate? This coordinate used to be x. So can you write down the value of y? Directly, if you know basic trigonometry, then y is nothing but r sin theta. And what is x? X is nothing but r cos theta. You can take the projection, no? If you know the projection. If you don't know the projection, then you can apply the basic trigonometry. What is cos theta? Cos theta will be nothing but x by r. So what is x? X is nothing but r cos theta. What is sin theta? Sin theta is nothing but y by r. So what is y? Y is nothing but r sin theta. Right? So it is very simple. So this is the relation between x and y, and from here, if you do the square of both of the side, on both of the side I am doing the square, y square plus x square, what that would be? That would be nothing but r square sin square theta plus r square cos square theta, sin square theta plus cos square theta will become 1. So this will become r square. So what is the value of r? Value of r is coming out to be under root x square plus y square. This is very simple thing. And can you find out the angle theta? Yes sir. If I divide both of these equations, so what I will be getting? Tan theta equals to y by x. So value of theta will be tan inverse y by x. So this is about the conversion. Okay. So simple conversion would be there. X and y coordinates would be given. If I want to convert it into the polar form, what it is known as polar coordinate system. If I want to convert it into the polar coordinate system, what I would do? X equals to r cos theta, y equals to r sin theta. My job would be done. Okay. So this is how I will convert it. And all I need to know is the limit. Limit of r, limit of theta. R will go from 0 to infinity and theta will go from 0 to 2 pi. So 0 to infinity, 0 to 2 pi. Complete whole circle will be completed. 0 to infinity, 0 to 2 pi, whole circle will be completed, whole coordinate system will be completed. So this is that 2D coordinate system that we have studied. Understandable? Let's study about rectangular coordinate system a bit more. Okay, so what we are going to study about? We are going to study about rectangular coordinate system. So if I want to move a small distance in x direction, let's just say I am at point P. I am at point P. If I am at point P, that means I have worked for distance x and I have worked for distance y. Right? I have worked for distance x and I have worked for distance y. If I want to move a small length, better word would be a small length in x direction, what would be that small length? That small length would be given by dx, and that small length in y direction would be given by dy. So from x to I want to go to x plus dx. So this distance would be dx, and from y to I want to go to dy. Sorry, from y to I want to go to y plus dy. So this distance would be known as dy. So which point I will be reaching? Basically here dx I have worked and here dy I have worked. So I will be reaching at this point. What will be this point? This point will be known as x plus dx, y plus dy. And what will be the small area? What will be a small area? So small area here would be dx dot dy. So in a rectangular coordinate system, a small area if I want to take, a very small area if I want to take, so what that would be? Distance in x direction, distance in y direction. So dx dot dy. So dx dot dy will be the small area. Understandable? Very small area in Cartesian, in a rectangular coordinate system if I want to take, that will be dx dot dy. So a small distance in x direction would be dx, a small distance in y direction would be dy, and a small surface area would be dx dot dy. Can I talk about the volume here? No, it is 2D. 2D will not have any volume, right? A simple piece of paper, will that have any volume? No, it is 2D only. 3D structure can have the volume. So here we will talk about only the distance and the surface area. What will be the surface area? Dx dot dy. What will be the distance? Distance will be in the x direction, it will be dx, in the y direction it would be dy. So let's make this diagram a bit better. So basically this is what we have done. We have worked for a distance dx, we have worked for a distance dy as well. Okay, and the small area, this small area is nothing but dx dot dy. Understandable? So it is like a movement in x direction and it is like movement in y direction, and multiplication of both of them is your small area. Movement in x direction, movement in y direction, multiplication of both of them is your small area. Understandable? Let's write down the same things in a polar coordinate system. In a polar coordinate system. So in polar coordinate system, what all parameters we are having? R and theta. These two parameters we are having. So what will be a small distance? What will be a small length in r direction? Moving a small length in r direction. So what will be that length? So let's make a small coordinate system here and let's show it here. So I am already at this point, which is at distance r and angle theta, which is at distance r, angle theta. I am at this point. Now I want to reach to some point which is r plus dr. R plus dr, and angle is theta only. I am only walking in the direction of r. So how much distance I am walking? I am walking the distance of dr. Right? I was already at r comma theta. Now I am reaching at r plus dr comma theta. That means I am walking a distance of dr. So if you are walking a small length in r direction, that means you are walking for dr distance. And if you are walking for a small length in theta direction, so how much will be that length? D theta? No, wrong. How much will be the length covered in theta direction? You are at angle theta. Where you want to reach? You want to reach at theta plus d theta, right? As of now, your vector is, your point P is making angle theta. Now what you want? You want the distance r only. What you want? You want the distance r only. Distance is r only. But your new point P dash, your new point P dash should be having a coordinate of, distance is r only, distance is r only, but angle should be theta plus d theta. Theta plus d theta, that means this angle has to be d theta. So I want the distance, I want the length. What do I want? I want length, but theta would have a unit of radian, right? What do I want? I want the length, that means I want this length. Are you able to understand this point or not? I want this length. I want this length. And what will be this length? Do you know? Arc length. Do you know the formula of arc length? Angle equals to arc length divided by radius. So see this structure. See this structure. See this structure. What is the angle? Angle is d theta. What is arc length? We are supposed to find out. Because how much we have moved? We were at this point, we have reached to P dash. That means this much we have moved, no? This length, let's call this length as dl. Okay? This length is nothing but dl. So we have moved for dl distance. So arc length is nothing but dl. And what is radius? Radius is r. So what will be dl? dl is r d theta. That means we have in the direction of theta. This is the direction of theta, no? In the direction of theta, we have moved for r d theta distance. Very, very, very important. very important. It is not d theta, it is r d theta, because we are talking about the length. Length will have a unit of meter, centimeter, kilometer, whatever it is. I don't want the radian, I want meter, centimeter, kilometer, all these units. So when I am moving in the direction of r, dr is fine, because r is the length, r is the length, r is the length or distance. So it will have a unit of centimeter only, but it is the angle. So in the angle, how much you are working? You are working r d theta. You are moving r d theta. Okay, so always remember that r d theta you are moving. And what will be a small area? What will be the small area? Here, moving in the direction of x, dx, moving in the direction of y, dy. Multiplication of both of them was the small area. So here what will be the small area? So here small area will be the multiplication of both of them. So here a small area in polar coordinate system would be given by r dr d theta. Simply the multiplication of both of them. R d theta multiply with dr. So it could be written as r dr d theta. So in the Cartesian coordinate system, if dx dy would be written, no. So I will replace it with r dr d theta. Would you be able to remember this or not? Absolutely, sir. Is that clear to you? So this is the confusion with a lot of students. They get confused here a lot of time that, sir, how dx dy is replaced with r dr d theta. Now is that clear to you? That moving a distance, moving a small distance in the direction of r was dr, and moving a small distance in the direction of theta was r d theta. So what is this small area that you are getting? So approximately you will take it as a rectangle only. So what was this distance? This distance was r d theta. This distance was r d theta, right? So r d theta into dr, this much area we are getting. So this is the small area in the polar coordinate system. Okay, very important. Your 60% of the problems will be solved from this one. But reasoning is also important. Is that clear to you? Okay, so moving a small distance in r direction is dr, moving a small distance in the direction of theta is r d theta. Why it is r d theta, that will be also clear to you. This diagram will be clear in your mind. So theta d theta into r will be the arc length. So r d theta. This diagram should be there in your mind. So r dr d theta will not be very difficult for you to write down. Understandable? Let's move to next. Let's move to this question. You need to draw x square plus y square equals to a square. Is it a line or a surface? Convert it into the polar form. So what question I am asking? First, draw x square plus y square equals to a square. X square plus y square equals to a square. What is the equation? X square plus y square plus a square. Have you seen this equation somewhere? Yes, sir. This is the equation of a circle. This you have already told us. In the basics, when we were studying about basics of calculus or basic mathematical foundation, in that you have already told that this is the equation of a circle. So x square plus y square equals to a square. What is this point? X equals to 0 comma a. This point is a comma 0. Right? So x square plus y square equals to a square. And the radius here is a. Radius here is a. So is it a line or a surface? It's a line only, no? When I am saying x square plus y square equals to a square, that means I am working on this line. I am working on this line. So yes, it is a line only. I am working on this line. Someone would say it is a curve, sir. Yes, it is a curve, but basically it is not a surface, no? You are simply working on a line. So is it a line or a surface? It is a line. It is a line. Now you need to convert it into the polar form. What is given? X square plus y square equals to a square is given. What I will do now? I will assume x as a cos theta, y as a sin theta. Right? And where my theta will be varying from 0 to 2 pi. Will that do my job? Yes, sir, absolutely. What I am doing is that I am doing nothing. I am in my xy plane only, I am making a vector a. In my xy plane only, I am making a vector a. I am making a vector a, which is making an angle theta with positive x-axis, which is making this angle. This vector a I am telling. So what is my x coordinate? X coordinate is a cos theta. What is my y coordinate? Y coordinate is a sin theta. And if theta goes from 0 to 2 pi, if theta goes from 0 to 2 pi, 0 to, where will be theta equals to 0? This will be your theta equals to 0. This will be your theta equals to 0. This will be your theta equals to 45 degree. This will be your theta equals to 90 degree. This will be 135. This will be 180. Then 215, sorry 225, then 270, then 315, then 360. So if I cover the complete angle, what I will end up making? I will end up making this circle. I will end up making this circle. Are you able to understand this point? Right? So here this A is fixed. No, this radius is fixed. You will not say that sir, my radius will be varying from 0 to A. No, it is a line. It is a line. You need to work on this line. So on this line, always your radius is A. Always your radius is A. Always your radius is A. Always the radius is A. This is simply a line. This is simply a line. Say yes or no. Where your radius is always A. Theta is varying from 0 to pi. So if someone would ask what is the value of dx here, so value of dx would be nothing but A differentiation of, basically dx by d theta we are doing. Dx by d theta if we do, what I will be getting? A differentiation of sin theta will, cos theta will be minus sin theta. So you can write down dx equals to minus A sin theta. Dx equals to minus A sin theta d theta. And what will be your dy? Dy will be A cos theta d theta. Someone would say then sir, from here dx dy is coming out to be minus A square sin theta cos theta d theta whole square. Here dx dy we will not even care about. Why is that so? Because it is a line, it is not a surface. It is a line, it is not a surface. It is not a surface. So why do we care about the area? We only care about the line. No, we only care about the small length. So small length is dx here, small length is dy here. So small length dx is nothing but minus A sin theta d theta. Small length dy is nothing but A cos theta d theta. Here radius A is fixed. So we are not even caring about dx dot dy. What happens with the student in integral calculus is that what they would think, sir, x equals to A cos theta, y equals to A sin theta, so then sir dx dy is this, then if I multiply both of them then I am getting something different. But sir, here you are saying dx dy equals to r dr d theta. So both are complete different thing. People interrelate both of them. Both are completely different thing. You need to see the locus. What is the locus? X square plus y square equals to A square. It is a line. When you do the line integration, you would either care about dx or you would care about dy. You will not care about dx dot dy. When you care about dx dot dy, that means you are caring about surface area. That means you will be caring about this surface area. And if you are caring about this surface area, then here your radius would be changing. Radius would be going from 0 to A, which will be our next example. So let's take our next example. You will be able to understand my point. What is the next example? This is the next example. X square plus y square less than A square. X square plus y square less than A square. So how do we make these kind of inequalities? I told you one thing, that first you make x square plus y square equals to A square. First you make this structure. What will be this structure? This structure will be nothing but simply this line only. So first I will make this structure here. So x square plus y square equals to A square I will make first. So that I have made. After that what I need to do? So this will be my these 2 points. After that what I need to do? I need to put some point. Let's just say either the region would be region inside or the region would be region outside. So what I would do? I would put some point 0, 0. Let's just put 0, 0 here. 0 plus 0 less than A square. So 0 is less than A square. Is it correct? Yes. That means what will be the region? Region will be the inside region. Right? This we have already drawn. X square plus y square less than A square we have already drawn. I told you it will be a disk. So it will be a disk. So this will be the region. Region inside. This will be the whole region. So is it a surface area or is it a line? It is a complete surface area, no? It is not representing a line. This particular inequality is not representing a line. This is representing a surface area. This is representing a particular surface area. Say yes or no? This is representing a surface area. X square plus y square less than A square is representing a surface area. This is the surface area it is representing. Understandable? And how it is the inner surface area, that is completely understandable. Just put 0, 0 here. It is satisfying the equation. That means inner area would be included, outer area will not be included. Right? So is it a line or a surface? It is a surface. It is not a line. Convert it into the polar form. So what is given? X square plus y square less than A square. So I will assume x equals to r cos theta this time and y equals to r sin theta. Why is that so? Why is that so? Look, if I need to cover this whole surface, if I need to cover this whole surface, if I need to cover this whole surface, starting from 0, this whole surface I need to cover. That means your r has to go from 0 to A. r has to go from 0 to a. R has to go from 0 to a, and theta has to move from 0 to 2 pi. Theta has to move from 0 to 2 pi. If this much you are able to get, then you will be able to cover the whole surface area. Just think about it. R is going from 0 to a. Just think about it. Just I will take this vector and अरे भाई ये वेक्टर कैसे हाथ में आएगा? Yes, just I will take this vector. R is going from 0 to a. R is going from 0 to a. R is going from 0 to a. 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 And theta is moving from 0 to 2 pi. 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 0 to a. 0 to 2 pi. 0 to a. 0 to 2 pi. 0 to a. R is going from 0 to a. That means R can take value 0 as well. R can take value a by 2 as well. R can take value a as well. Any value it can take. It can take value 3a by 4 as well. It can take value a by 4 as well. A by 2, 3a by 4, a. Any value it can take. And along with that, theta can also vary from 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. So it will cover the whole surface. Are you able to understand this point or not? So here you will talk about dx dy. So what will be the value of dx dy here? What will be the value of dx dy here? Here the value of dx dy would be nothing but r dr d theta. Is that clear to you or not? So it's a surface. When we are talking about the surface, then dx dot dy would be equals to r dr d theta. Here you will not say that, sir, let's talk about dx dy. Sir, x equals to r cos theta, y equals to r sin theta. Let's do one thing, sir. What do we do? Sir, dx equals to r cos theta d theta. Some people differentiation they will do. They will keep r as it is, and sir, dy equals to r cos theta d theta, and then sir multiply both of them, dx dy. Some answer r square sin theta d theta, whatever it is, whatever the process that you are doing, this whole process is absolutely baseless. This is baseless. This is baseless. So you need to know what we are interested in. Are we interested in the surface, or we are interested in the line? So yes, we are interested in the surface. Since we are interested in the surface, I need to cover the whole surface. So r has to go from 0 to a, and theta has to cover from 0 to 2 pi. If this is the scenario, then my job would be done. R is the distance from origin. Always remember, what is R? R is the distance from origin. 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 It is going from 0 to a. 0 to a. 0 to a. Along with that, it should move as well. For moving, what do we have? We have the angle. So for moving, we have the angle. We have the angle. So is that clear to you? So this is the r that I am assuming. This is the r that I have assumed. This was my r, and this was my angle theta, which is going from 0 to 2 pi. You are not able to see it, but if you zoom in, you will be able to see it. Understandable? Is that clear? So this much process should be clear to you. That where we are interested in the surface, are we interested in the surface, or we are interested in the line? When we are interested in the surface, we need to care about the surface. Dx dy would be replaced with r dr d theta. And why it would be replaced with r dr d theta, that also I have told. In the direction of theta, how much do you move? In the direction of theta, we always move r d theta. In the direction of r, how much do we move? We move dr. So what is the total surface area we cover? R dr d theta, right? X equals to r cos theta, y equals to r sin theta. We can assume our job would be done. Okay. Now someone would be saying that, sir, every time we will have to draw this diagram, how we will think what will be the range of r? Sir, range of theta is very simple, sir. It will be 0 to 2 pi. How we will think what will be the range of r? So simple trick is that whatever that you have assumed, no, just put this here. Your assumption, whatever you have assumed, no, just put this here. What you will be getting? R square cos square theta. What you will get? R square cos square theta plus r square sin square theta. R square cos square theta plus r square sin square theta less than a square. So from here, what you will see? R square should be less than a square, or you can say r less than a. Now someone would say that, sir, here plus minus should come, all these things should come, but both are the positive quantity. No, radius is also positive, r is also positive, because r is the distance only. So r has to be less than a. That means r will go from 0 to a. So just although this was a very simple expression, you would be able to draw the graph and you would be able to comment that, sir, r will be going from 0 to a. But sometimes the expression might be complex. So if expression is complex, what you would do? Simply whatever that you have assumed, put that here, you will be able to understand that r has to be less than a. That means it will go from 0 to a. That's it. Okay, so here less than equal sign is not there, no. So that's why let's put it from 0 to a. Is that clear to you? So whatever that you have assumed, just put it here, and from here you will be able to understand that r square should be less than a square, or r has to be less than a. So sometimes expression might be complex where you might not be able to draw the diagram. So there intuitively you will have to think, okay sir, theta will take the whole range, but what about the range of r? I am not able to think, sir, what is the boundary? So for that, what you will do, you will simply put your wording here, whatever the assumption that you have made, that you will put here, and you will be able to get the range of r. That will be from 0 to a. Understandable? Okay, so this is the 2D coordinate system. In 30 minutes we have discussed. 2D coordinate system was very straightforward, very simple. Let's do the revision right from the beginning. Rectangular coordinate system we already know. Polar coordinate system, r comma theta. R is the distance from origin towards your point, making an angle of theta with positive x-axis in the anti-clockwise direction. Right? X equals to r cos theta, y equals to r sin theta. X square plus y square equals to r square. R is under root x square plus y square. Theta is tan inverse y by x. All these things you don't need to remember. You will be able to derive it within seconds in the examination hall. Moving a small distance in x direction dx, moving a small distance in y direction dy. What will be the small area? Dx dot dy. Similarly, for polar coordinate system, moving a small distance in r direction dr, moving a small distance in theta direction is r d theta. Very important. D theta you will move, but you are talking about the distance. That means you are talking about the arc length. That will be r d theta. So what will be the small area? That will be r dr d theta. R dr d theta, very important. So dx dy, that small area here, that was dx dy, that will be replaced with r dr d theta in the polar coordinate system. Now x square plus y square is a line or a surface. It is a line. So if it is a line, so either we will care about dx or we will care about dy, because we are talking about the length. Since it is a line, that means we are talking about the length. So either we will care about dx or dy. Here your radius is constant, so x equals to a cos theta I am assuming, y equals to a sin theta I am assuming, with theta going from 0 to 2 pi. Dx value I can write down, dy value I can write down. X square plus y square less than a square. So here, what is the scenario? Here it is a surface. It is representing a surface. So I am interested in the surface where radius is going from 0 to a and theta is going from 0 to 2 pi. Radius is going from 0 to a, theta is going from 0 to 2 pi. X equals to r cos theta, y equals to r sin theta. Understandable? If sometimes in some questions, if I am not able to understand what is my limit of r, then what I would do is that I will simply put my assumption in these equation and I will be able to get my limit of r. So r is going from 0 to a and theta is going from 0 to 2 pi. If I cover the whole distance 0 to a and theta 0 to 2 pi, I will be able to cover the whole surface area. Is that clear to you? Now we are going to talk about 3D coordinate system. Okay. So in 3D coordinate system, what do we know? X, Y, Z. So this is your x, this is your y, and this is your z. X, y, z coordinate we are making, and I need to reach some point P, which is x, y, z. How will I reach to this point P? Very simple, sir. This is the Cartesian coordinate system that we are studying, which we already know. What you would do, sir? You will work for a distance x, you will work for a distance y in y direction, and then in the z direction you will work for a distance z, and you will reach the point P. And you will reach the point P, right? You will work for a distance x in x direction, you will work for a distance y in y direction, and you will work for a distance z in z direction, and you will reach the point P. That is very simple, right? What will be the range of x, y, z? So the range of x, y, z would be x will be going from minus infinity to infinity, y will be going from minus infinity to infinity. Here only positive axis I have made, but negative axis will also be there, no? Right? Negative y would be there, negative x would be there, negative z would be there. So if you want to cover the whole coordinate system in 3D, so you have to take these limits going from minus infinity to infinity. Now what is written here? Let's check that out. So what will be the small distance in x direction? That will be dx. That I don't need to show. If you are here, that means if you would want to work for some more distance in x, that will be dx. Some more distance in y, this is actually y only. If you want to work for some more distance in x, that will be dx. Some more distance in y, that will be dy, and some more distance in z, that will be dz. So here some 3D structure you will be able to make. That 3D structure also you will be able to make. So here we will be able to talk about the volume as well, since it is a 3D structure. Okay, and we will be able to talk about the surface area as well. So some small distance we have took, some small distance we have moved. So in the x direction I will move dx, in y direction I will move dy, in z direction I will move dz. Here what did I do? Did you understand? Basically I started moving. I am at point P, no? I am at point P. I am at point P, and point P is nothing but x comma y comma z. Now I need to move a small distance dx in x direction. Okay. Now what is y direction? This is your x direction, no? This is your x direction. This is your y direction, and this is your z direction. So small distance dx in x direction, small distance dy in y direction, and small distance dz in z direction. Small distance dz in z direction. Understandable? So similarly, dx here, if this is dx, then this will also be dx. If this is dy, then this will also be dy. And if this is dz, then this will also be dz. So here we can make a small volume as well, no? Similarly, we can make a small volume as well, since it is 3D. So this small volume also we can make. So dx distance you know, dy distance you know, and dz distance you know. This is what we have done. So small distance dx, small distance dy, small distance in z direction would be dz. And what will be a small surface area in xz plane? Xz plane. Here, what will be the small surface area? What will be the small surface area? So what is this distance? This distance. What I am talking about? What will be this distance? What will be this distance? This distance is dx. And what is this distance? This distance is dz. This is your dz. And the other one that I have made dz, not dx. The vertical one is dz. This one is dx, and this one is dy. So in zx plane, if I need to take a small area, what that would be? Sir, here this distance would be dx and this distance would be dz. So what will be that small area? That would be nothing but dx into dz. Dx into dz. Similarly, in yz plane it will be, sorry, in xy plane it will be dx dy. In yz plane it would be dy dz. And what will be your small volume dv? What will be this volume? What is the meaning of volume? Area of base. What is the area of base? Dx dot dy. Multiply with height. What is height? dz. So your volume is dx dy dz. So you are working a small distance dx, you are working a small distance dy, you are working a small distance dz. Multiply all three of them, you will get the volume. Dx dy dz, multiply all three of them, you will get the volume. And if you want the surface area, then these are the surface area. In xz plane, just talk about x and z. That means dx dz. In xy plane, only talk about x and y. So dx dy. In yz plane, only talk about y and z, dy dz. That's it. Understandable? So this is your Cartesian coordinate system that we already studied. Now another coordinate system we need to study, that is cylindrical coordinate system. Again, I need to reach to this point P. I need to reach to this point P. This time, what your friend said, that you are at the origin, your friend is here. This time what your friend said that you do one thing, you come for some distance rho, okay, and then perpendicularly you come for distance z. You will find me. Here you are standing. So what he said, you come for a distance rho from the z axis, radially you come for a distance rho. Okay, this distance he is saying you come for a distance rho. For rho distance you come. Okay, and then you go for z. So is it enough? What is rho here? Rho is radial distance from z axis. Radial distance from z axis. So is it enough, whatever that he said? Radial distance from z axis, for in a rho you could have come in this manner as well, no? You came for rho distance in this manner and then you went for z distance. You would reach here, or someone would have come here, then he would reach here. Someone would have come here, he would reach here. Someone would have come here, he would reach here. Right? So what he needs to say? He needs to say that you will make a a rho distance making an angle of phi with positive x axis in anti-clockwise direction. Making an angle phi with positive x axis in anti-clockwise direction, come for distance rho and then come for z. That means its coordinate would be rho, phi and z. Let me tell it again. How will you reach to this point P? What your friend will say at the origin. Radially come for distance rho, making an angle of phi with positive x axis, and then in the z direction move for distance z. You will reach to this point P. Basically, if you are in 3D, no. If you are in 3D, then you would need 3 coordinate x, y, z. If you are in 2D, you need 2 coordinate x, y or r theta, right? Either x, y or r theta, because it is a 2D coordinate system. So if it is a 2D coordinate system, you need 2 coordinates. If it was 1D, that means only on one line he can call it. That means you work for 5 km, you work for 6 km. In that manner, he can say. But if you are in 2D, then he would need at least 2 coordinate x, y or r theta. If you are in 3D, you would need 3 coordinate x, y, z or rho, phi, z. Another one could be there, that also we will study. So this is known as cylindrical coordinate system. Why it is known as cylindrical? Can you guys think on your own? Cylindrical. It is kind of making a cylinder only, no? Why it is making a cylinder? We will study about it. Don't worry. Okay. So what is rho? Rho is the radial distance from z axis. What is phi? Phi is the angle made with positive x axis in anti-clockwise direction. Right? And what is z? Z is z only. Z is the distance. This is distance z. What could be the value of rho? Rho is the radial distance from z axis. Rho here, rho here, rho here, rho here, rho here, rho in this manner. Are you able to understand this point? Rho is the distance from z axis. That means value of rho could go from 0 to infinity. Do you agree to this point or not? 0 to infinity. Do you agree to this point or not? Value of rho will be going from 0 to infinity. It is the radial distance. Again, just assume this is the 2D surface. Assume this is the 2D surface. If I want to cover this whole surface, I want to cover this whole xy plane. That means rho has to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In the same manner, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In that manner, this complete row will be completed. Is that clear to you? Right? What should be the range of phi? That means rho should not be in only one direction. Rho should be in this direction as well, 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 in this direction as well. What does that mean? That means this phi should be completely circular. Right? That means phi should go from 0 to 360 degree. Phi should go from 0 to 360 degree. Is that clear to you? So this is phi, which should go from 0 to 360 degree. So if rho is going from 0 to infinity, right? Phi is going from 0 to 360 degree. That means we have covered the whole xy plane. Now we need to cover the z axis as well, no? Z plane as well. That means we need to go from minus infinity to infinity in z axis. Infinity cannot be reached. That's why I am not putting the equal sign. Is that clear to you? Again, rho is going from 0 to infinity. Phi is going from 0 to 2 pi. And z is going from minus infinity to infinity. In that manner, we are covering the whole surface. Not surface, whole volume we are covering. That means all the coordinates we are covering. Here, every coordinate if we need to cover. In 3D plane, everything if we need to cover. That means x should go from minus infinity to infinity. Y should go from minus infinity to infinity. And z should go from minus infinity to infinity. In that manner, if I want to cover completely, then this is how it will be completed. If I want to cover completely here, how will I be able to cover completely? That rho is going from 0 to infinity in the whole direction, in 0 to 2 pi direction, and z is going from minus infinity to infinity. This is how I will be able to cover it completely. This is how my cylindrical coordinate system would be completed, or I will be able to cover all the coordinates here, any coordinate you take, Let's just take any random other coordinate. Do I have the diagram for that? Yes, I have the diagram for that. Basically, let's take here I have made minus x axis as well, I have made minus y axis as well, and minus z axis as well. Now I need to cover, let's just say I need to reach at some point which is, let's go here. which is x equals to minus 2, x equals to minus 2, x equals to minus 2, y equals to 2, and z equals to 3. This is the point where I want to reach. This is your minus axis, you know. So this is x equals to minus 2, y equals to 3. This is your y axis, this is your minus x axis, and minus 2, 2, 3. This point I want to reach. Right? This is the point where I want to reach. So how will I reach? What your friend would say? Your friend would say that radially from z axis you will come here, making an angle of phi with positive x axis, making an angle of phi with positive x axis. In 2D, this is in the 2D plane only, making an angle of phi with positive x axis. Whatever this angle is there, I don't care. This radial distance would be rho. This radial distance that your friend has said, this will be rho. And once you have reached here, what you do? You work for distance z. You work for this distance z. This is how you will be reaching this point. Now what will be the value of this rho? That I can find out. What will be the value of this rho? Can you find out? This point was minus 2. This point was minus 2. This point was also 2, right? Because you can see the coordinate minus 2, 2, 3. That means on x axis you have worked for minus 2. That means this is your minus 2, or this distance is 2. This distance is 2. This distance is also 2. So here in xy plane there is a right angle triangle. If you see here closely, it is a right angle triangle only. If I only make the xy plane. In xy plane what is happening? In xy plane what is happening is that this is your x axis, this is your y axis. This angle is 90 degree. Okay, I hope you know this angle is 90 degree. Xy plane in 90 degree. What you are doing? You are moving for a distance rho, making an angle of phi with positive x axis. This is what you are doing. You are working for a distance rho. Right? So how much will be, so how much are you working in x direction and how much are you working in y direction? So in x direction we are working rho cos phi, and in y direction we are working rho sin phi, and in z we are working for z only. So what is your x? X is nothing but rho cos phi. What is your y? Y is nothing but rho sin phi. And what is your z? Z is z only. So can you find out the value of rho here? Yes sir, rho is coming out to be under root x square plus y square. What is the value of theta? Sorry, sin phi. What is the value of phi? Here theta we are not even introducing. What is the value of phi? Value of phi is tan inverse y by x. Is that clear to you? So similarly, here you are working for distance 2, here working for distance 2. So your rho is coming out to be under root 2 whole square plus under root 2 whole square, that is under root 8, that is 2 root 2. So this is 2 root 2, this distance is 2 root 2. What is this angle? This much angle also we can find out by basic trigonometry. By basic trigonometry, we can find out the angle as well. This is 2, this is 2, so I can find out this angle. Can I find out this angle? This angle. So here this distance is 2, this distance is also 2. So 2 by 2, this angle will be 45. This angle will come out to be 135 degree. Okay. You can do it on your own if you want to do. How did I do it? Basically, let's make this plane. Which plane I am making? I am making minus x y plane. Which plane I am making? Minus x and y plane. This plane I am making. So in this plane what I am doing? I am moving for a distance rho. I am moving for a distance rho. Right? So on x axis I have worked for minus 2 distance. Minus 2 distance. And on y axis I have worked for plus 2 distance. Plus 2 distance. So this distance is 2. This distance is also 2. So this angle I am finding out. This particular angle I am finding out. Minus xy plane I have made. Minus xy plane I have made. This particular angle I am finding out. So 2 divided by 2, this will be tan 45 degree. So this angle will be 45 degree. So this angle will be 45 degree. And I already know that from here to here, this angle is already 90 degree. So what will be your phi? Phi will be your 90 plus 45. That means 135 degree. So what your friend will say? Your friend will give you the coordinate of this P point. Let's just say this point is P. So your friend either can say minus 2, 2, 3, or he can say that work for a distance of 2 under root 2, making an angle of 135 degree with positive x axis and then in the z direction walk for a distance of 3 meter. You will reach me. So both are the same thing. This thing or that is equals to p minus 2 comma 2 comma 3. Both are the same things. So this is how your friend can give you the coordinates. So it is known as your cylindrical coordinate system. Is that clear to you? Is this scenario clear to you? That how from xyz to I have moved to rho phi z. Radial distance rho, making an angle of phi, moving in z direction. That's it. Very simple thing. xyz we used to move. In place of xy we are moving rho. Nothing else. It is like that 2D thing only. If you look it closely, z is remaining the same. On the first page what we did? Xy we converted into r theta. Here xy we have converted into rho phi. So if you look it closely, only this 2D thing that we converted, that's the same thing here. Xy has been converted into rho phi, nothing else. Z is as it is. Are you able to relate with the 2D? This is how we came. Rho, making an angle of phi. Rho cos phi, rho sin phi. Rho cos phi, rho sin phi. That is your x and y coordinate. I hope you are able to relate very easily and very smartly as well. Okay. Walking a small length in rho direction, what that would be? In rho direction you are walking a small length, what that would be? Rho is already a length, you are walking a small length in rho direction, what that would be? D rho. If you are walking a small length in z direction, what that would be? If you are not able to understand, I will have to make separate coordinates. So where shall I make? Here I will make. What plane I am making? I am making the xy plane. This is your x, this is your y. What is rho? Rho is the radial distance. Rho is the radial distance. This is your rho. Rho is the radial distance. Then you will reach here. Now you are going for another d rho distance. Another d rho distance. So where you will reach? You will reach as at rho plus d rho. Right? And what about z? What about z coordinate? So let's make yz plane. Or xyz plane only I will make. So let's just say you are at some point. Let's just say you are at some point here. Okay, you are at some point here. So you are at some point z. Now you need to work for some more distance. So that would be dz. Right? So where you will reach? This was your z coordinate. So here you will reach z plus dz. Right? So small distance in z direction would be dz. Small distance in the direction of phi. What that would be? Write it down on your own and don't write it wrong. What will be the small distance, small length covered in the direction of phi? What is phi? In the direction of phi, walk for a small distance, don't mess it up. First make the angle phi. First make the angle phi. In xy plane, you had the angle phi, right? This is your x, sorry, this is your y, this is your x. Here in between some coordinates are there. At some rho distance that I don't care. This is the angle made with the positive x-axis in a anti-clockwise direction. This is phi. So from phi to d phi we need to go. From phi to d phi we need to go. Phi to d phi we need to go. Phi to d phi we need to go. Right? So phi to d phi. So from this point to this point we have moved. This point to this point we have moved. So how much we have moved? What was this distance? This distance was rho. This distance was rho. So how much will be this radial distance? How do I show this distance? Rho I am not changing. No, rho is the same. I am not moving in the direction of rho. This is also rho only. This is also rho only. So how much will be this distance? How much will be this distance? This distance will be rho d phi. So this distance will be rho d phi. Okay. So in rho z plane, what will be your surface area? D rho dz. Directly I can write down. No, simply like this. Simply in this manner. Here we have written down. In x direction, y direction, dx, dy. So in xz plane, dx, dz. So similarly here, in rho z plane, d rho dz. In rho phi plane, it will be rho d rho d phi. And in z phi plane, it will be rho d phi dz. Nothing you need to mug up, okay? Nothing you need to mug up. Everything will be all in this whole lecture. Only thing you need to do is to understand, nothing else. Only you need to understand the things, nothing else. Understanding is important here. How we will be using it, that will be clear in the integral calculus. Integral calculus will become a cakewalk for you, which used to be the toughest topic for you in engineering mathematics. That will become very simple if you just follow this process. This lecture is very important for that. Okay, and what will be the volume? Sir, for the volume, here in this scenario, what was the scenario? Dx into dy into dz. So here what will be the volume? Rho into d rho into dz into d phi. Rho, d rho, dz, d phi. So this is also important. If I'm asking you to remember something, like I'm asking you to remember the volume here, what will be the volume? So volume you will be able to understand. No, sir, there are three coordinates, rho, phi, z. So how much do I move in the direction of rho? Sir, rho, d rho I move. How much do I move in the direction of phi? Sir, rho, d phi I move. How much do I move in the direction of z? Sir, dz I move. So what will be the volume? Rho, d rho, d phi, dz. So very easily you will be able to write down. If I ask you about the surface area, will you be able to write down? Yes, sir. In this plane, surface area would be this much. Otherwise, this will be the surface area. Otherwise, this will be the surface area. In that manner, you will be able to write down the surface area as well. Only thing you need to know is that, sir, how do I move? In the direction of rho, d rho. In the direction of z, dz. In the direction of phi, rho, d phi. Right? In the direction of phi, rho, d phi I move. Why is that so? Because, sir, phi is the angle. So if I am moving d phi, that means I am actually moving the distance of rho d phi. Okay, I need the distance. So rho d phi distance I am moving. So will I be able to write down the volume? Yes, I will be able to write down the volume as well. So very easily I will be able to write down all these things. Okay, now we need to make some locus. You can try doing it on your own. I will take a break and then I will come back. You draw this locus. Locus means make the cylindrical coordinate system. Keep rho as 4. Rho is constant. Theta is also constant. Phi is also constant. This is not theta. This is phi. This is not theta. This is phi. Phi is also constant, which is pi by 3, and z is varying from minus infinity to infinity. So what kind of locus you will get? Will you get a surface? Will you get a line? Will you get a volume? And what kind of a line or surface or volume you will get? That you can try to make. Rho equals to 4 you need to take constant. Phi equals to pi by 3 you need to take constant. What is rho? That you know. What is phi? That also you know. What is z? That also you know. Try making the locus on your own. Similarly for this one. Similarly here as well. This is phi. This is phi. Okay. Similarly, all these locus we will try to make. All these locus we will try to make. Okay. So I will take a break, then I will come back. I will drink some water. You can also drink some water, and then we will try to make these locus. I hope you are enjoying this lecture. It is very, very, very important for understanding integral calculus. Integral calculus will become very easy and very straightforward after all these scenarios. Okay. Let's meet and make these locus. Very straightforward locus these are. You can try on your own. Yeah, welcome back. So did you draw the locus? Let's get started. Rho equals to 4, phi equals to pi by 3. So x, y, z we will make x, y, z. Pi equals to pi by 3. That means with the x axis you need to make the angle of pi by 3. Pi by 3 means 60 degree. So you are making an angle of 60 degree with x axis, right? Making an angle of 60 degree with the x axis, and rho is 4. Distance is 4. 60 degree angle, pi by 3 angle, and the distance, radial distance from z you need to cover, that is 4. This distance is 4. And z is varying from minus infinity to infinity. Z can vary from minus infinity to infinity. So you are at this point, this distance is 4 only. Okay, this distance is 4. This distance is 4. But now z is varying from minus infinity to infinity. Z is varying from minus infinity to infinity. So z can vary. Z can take any value. Z can take value. Here what is the value of z? 0. Here what is the value of z? 1. Here what is the value of z? 2. What is the value of z? 3, 4, 5, 6, 7, 8. Downward minus 1, minus 2, minus 3, minus 4, minus 5. In that manner, the value of z will keep on varying. Right? So this is how the value of z will keep on varying. So what is the equation? What is the scenario? This is a line. Say yes or no. Right? What they are saying? Rho is 4, making an angle of pi by 3. but z can vary any value. Z can take any value from minus infinity to plus infinity. So plus infinity to minus infinity, z can take any value. So it is simply a line. And what will be a small portion on this line? A small portion on this line will be dz. Right? A small portion on this line will be dz. Basically, in the examination, this line would be given. You should be able to comment on this line. So in this particular line, sir, the value of rho is constant. On this line, the value of rho is constant, which is equals to 4, and then, sir, angle is also constant, which is equals to pi by 3, and z is varying from minus infinity to infinity. So you should be able to make both of the things. Okay. If the equation of line is given, then, sir, you would see that from radial distance z, like radial distance. What do I mean by radial distance? Like from the z axis, what is the distance till this point? So that will also be 4. From z axis, what is the distance till this point? So that will be 4 only. Always the distance is 4 only. Always the distance is 4. And how much angle it is making with the x axis? Positive x axis. This is your positive x axis. No, how much angle it is making? How much angle these lines are making? How much angle these lines are making? These lines are making angle pi by 3 only. Right? So this distance remains always 4. This distance always remains 4. And angle remains always pi by 3. So this is the equation of a line. And a small portion on this line is dz. Let's make next one. Angle is fixed, which is pi by 3. Z equals to 4 is also fixed, but rho is varying from 0 to infinity. So what we will get? So again, let's make the xyz plane, not plane, xyz coordinates. This is your x, this is your y, this is your z. Z equals to 4 is fixed. Z equals to 4 is fixed. Rho equals to pi by 3, 2 pi by 3. 2 pi by 3 means it is greater than pi by 2. This angle is pi by 2 only. What is the meaning of 2 pi by 3? 2 pi by 3 means 120 degree. 2 pi by 3 means 120 degree. This much angle is already 90 degrees. So 90 degree plus 30 degree. So we need to make minus x axis as well. We need to make minus x axis as well. Minus x axis as well. So I have made minus x axis as well. So how much angle we are talking about? We are talking about 120 degree angle. 120 degree angle. Right? And the value of z is also fixed. Value of z is also fixed. But the value of rho is varying. What is rho? Rho is the radial distance. Right? Rho is the radial distance. So radial distance is varying. That means basically at z equals to 4, the rho will be varying in this manner. Are you able to understand this point? So this will be the equation of line. Again, it will be a line only, but this kind of line it would be. This kind of line you will be getting. Rho is varying from 0 to infinity. Are you able to understand this point? It will be tough to show. Like if I had taken a simpler angle, no, let's take a simpler angle. Let's not take 120 degree. Otherwise, it will be tough to show. Let's take 60 degree angle only. Okay. Otherwise, visualization will be difficult. But here, our important point is to understand the concept, no, not to take up the question to be on the difficult level. So those who are able to visualize, they are already able to visualize. But let's take the angle to be 60 degree, so that the visualization will become easier. So now we don't need to make a negative angle. So angle is 60 degree. Angle is 60 degree. So angle made with x-axis is 60 degree. So angle made with x-axis is 60 degree. But the line will not be here. The line will be at z equals to 4. No, the line will be at z equals to 4. This will be the line. This will be the line. Rho will be varying from 0 to infinity. Rho will be varying from 0 to infinity. Rho will be varying from 0 to infinity. Here, what will be the value of rho? Here, the value of rho will be 0. And here, what will be the value of rho? Value of rho will be infinity. Now, the same, if you take the projection of this line on a xy plane, if you take the projection of that line on a xy plane, then what angle it would make? It would make the angle of 60 degree. I hope it is understandable to you. I hope it is understandable to you. So basically, this angle is 60 degree with the making an angle 60 degree, making an angle of 60 degree with positive x-axis at z equals to 4. You are going rho from 0 to infinity. Radial distance from z axis. Radial distance from z axis. Rho going from 0 to infinity, making an angle 60 degree. Making an angle 60 degree. So this is the 60 degree angle. I hope you are able to visualize in 3D. Let's try to make you visualize in 3D. This is the xz plane. So it is making an angle of 60 degree. Making an angle of 60 degree. Making an angle of 60 degree, rho going from 0 to infinity. Understandable? Okay. Let's next one. Rho equals to 3, z equals to 2, phi going from 0 to 2 pi. Think about it and make it on your own. And yeah, what will be a small portion on this line? The small portion on this line will be nothing but d rho. Right? Small portion on this line will be nothing but d rho. x, y, z. Rho equals to 3, z equals to 2. Z equals to 2. This is your z equals to 2. Rho equals to 3. That means from z equals to 2, radial distance 3. Radial distance 3. Radial distance 3. But theta is varying from 0 to 2 pi. That means theta will vary from complete 0 to 2 pi. Complete angle it will cover. What does that mean? It will be a circle. Did you understand this point? Here rho equals to 3 is fixed. Rho equals to 3 is fixed. Z equals to 2 is also fixed. So here what will be the value of rho? 3. What will be the value of theta? Here value of theta would be something else. Like if I take the projection of this line, if I take the projection of this blue line, what will be the value of theta? Here value of theta might, let's just say value of theta is pi by 4. Value of theta is pi by 4. So 3, not theta, it is 5. Okay. So rho comma pi comma z. So 3 comma pi by 4 comma z value is 2. But phi is varying from 0 to 2 pi. Phi is varying from 0 to 2 pi. That means complete all the angles. When phi equals to 0 degree, you will be at this point. When phi equals to 0 degree, you will be at this point. When phi equals to pi by 4, you are at this point. When phi equals to pi by 2, you will be at this point. When phi equals to 180 degree, you will be at this point. When phi equals to 270 degree, you will be at this point. When phi equals to 360 degree, you will be again at this point. When phi equals to 315 degree, you will be at this point. When phi equals to some other angle degree, you will be at this point. So in that manner, you will be covering as circle only. Is that clear to you? Say yes or no. And what will be a small portion on this curve? What will be a small portion? What will be a small portion on this curve? What will be a small portion? That small portion will be nothing but rho d phi. Right? A small portion on this curve will be rho d phi. Why is that so? That is completely understandable to you. In the direction of rho, it was d rho. In the direction of z, it was dz. Here in the circular direction, it will be rho d phi. Why is that so? Because if I cover a small distance d phi, if I cover a small distance d phi, if I cover a small distance d phi, let's just say it was rho equals to 3. If I cover a small distance d phi, here the angle was phi, which was pi by 4. If I cover a small distance d phi, then what will be this distance? A small distance. What that would be? This was rho only. So this small distance would be rho d phi only. A small distance would be nothing but rho d phi. So a small distance on this circular portion will be nothing but rho d phi. Understandable? Well and good. Crystal clear? Okay, so this locus is also clear. What is this locus? This locus is a circle, or you can call it line as well. It is a line only, no? It is a line. It is not a surface area. Basically, it is not a surface. It is simply a line only. This is also a line. This is also a line. This is a line. This is a line, and this is also a line only. It is not a surface. Understandable? Let's make the next one. Rho equals to 4. This time z is also varying and phi is also varying. But rho equals to 4 is fixed. What do you think? What you will end up making? Rho equals to 4 is fixed. Rest all are varying. I hope you are able to visualize these locuses. Z equals to 2, rho equals to 3, but phi is varying. Similarly, here rho is fixed. Rho equals to 4 is fixed. Z will vary. Z will go from minus infinity to infinity. Here let's make a minus infinity downwards. And phi will also vary. This is Z, this is X, this is Y. Z will go from minus infinity to infinity, minus infinity to infinity. And phi will vary from 0 to 2 pi. That means complete circle it will make. What does that mean? It will end up making a cylinder. Right? It will end up making nothing but a cylinder. Let me make the cylinder and you will be able to understand. Cylinder which is extended till infinity. From minus infinity to infinity. It is extended till infinity. Cylinder which is extended till infinity. Why is that so? Because the value of rho is fixed, no? How do I show it in 2D? In 3D, how do I show? Like at this point, what is the value of rho? At this point, let's just say this point is in xy plane only. So the value of rho is fixed, which is equals to 4. The value of rho is fixed, which is equals to 4. Radial distance from z axis, which will be always 4. Radial distance from z axis, it will be always 4. Always 4. Always 4. Here also it is 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 4. Okay, to the end of the surface. So it is, isn't it the surface? Only the surface it is. I am talking about only the surface. Rho equals to 4. If you just talk about a cylinder, let's just consider this as a cylinder, and in between there is this axis, z axis. In between there is z axis. In between there is z axis, right? So rho equals to 4 is fixed. Phi is varying from 0 to 2 pi on this surface. Phi is varying from 0 to 2 pi. Phi is varying from 0 to pi, and z is going from minus infinity to infinity. This is z. This is z. Vertical hand that I am showing. Z is going from minus infinity to infinity, and phi is varying from 0 to 2 pi, and rho equals to 4 is fixed. Right from the center inside, right from the center till this point, till this surface. Rho equals to 4 is fixed. Rho equals to 4 is fixed. Phi is varying from 0 to 2 pi, and z is varying from minus infinity to infinity. Phi is varying from 0 to 2 pi, z is varying from minus infinity to infinity. Is that understandable to you? So this is the cylinder we will be able to make. Is that clear to you? This is the cylinder that we are making, right? But this cylinder will be extended till plus infinity and minus infinity, right? Plus infinity and minus infinity. This will be going till plus infinity here and minus infinity here. Is that clear? Rho equals to 4. Rho equals to 4. Everywhere rho equals to 4. Everywhere rho equals to 4. Right? Radial distance from z axis will be always 4. Radial distance from z axis will be always 4. Radial distance from z axis is always 4. Understandable? Let's go to the next one. Z equals to 3. Z equals to 3 is fixed. Rest everything is varying. Z, this is z, this is x, this is y. Z equals to 3 is fixed. Rest everything is varying. Rho is varying from 0 to infinity, and phi is varying from 0 to pi. Phi is varying from 0 to pi, that means around 3 from 0 to 2 pi will be a circle. And rho is varying from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In that manner it will be varying. What does that mean? It will make a circular disc this time. It will make a circular disc. Why I am calling it a disc? Because rho is also varying. No, this time rho is also varying. Rho is going from 0 to infinity. So this disc will be there, but it will be extended till infinity, extended till infinity, extended till infinity, extended till infinity. It will be going till infinity. It will be going till infinity. Till infinity it will be going. Till infinity it will be going. Is that understandable to you? Z equals to 3 is fixed, but rho is varying, no? Rho. This is your rho. Rho is varying. Rho equals to 0, rho equals to 1, rho equals to 2, rho equals to 3, rho equals to 4, rho equals to 5, rho equals to 6, rho equals to 7, rho equals to 8, rho equals to infinity. And what about theta? What about phi? So with respect to z axis, phi is 0. Then phi will move and again till 360 degree. 0 to 360. 0, pi by 4, pi by 2, 3 pi by 2, and in that manner again 0 till 360 degree. In that manner it will keep on going. In that manner it will keep on going. So it will be like a circular disc completely. And yes, let's take a small surface area. This is the surface area. I hope you are able to understand. This will be a surface area, no? This will be a surface area. So what will be a small surface area here? What will be a small surface area? What will be the small surface area here? So basically, if this is the surface area, if I take a small portion here, if I take a small portion on this bottle, if I take a small portion on this bottle, if I take a small portion on this bottle, what will be that portion? That I am asking. What will be this portion? What will be this portion? What will be this small area? Can anyone tell? That will be, sir, rho d phi into dz. Look, what is the curvature? Just think about it. Just think about this bottle. What is the curvature? In the curve, how much distance I am moving? Curve distance. Curve distance. In the curvature, how much distance do I move? Rho d phi. In the z direction, how much distance do I move? dz. In the curve, how much do I move? Rho d phi. In the z direction, how much do I move? dz. So in the curvature, I am moving rho d phi. In the z direction, how much I am moving? dz. So rho d phi dz will be the surface area. What is the simple trick? The simple trick is that, sir, who are varying? Z is varying and phi is varying. Who is varying? Z is varying, phi is varying. So what is the distance traveled in the z direction? dz. What is the distance traveled in phi direction? Rho d phi. So what will be the surface area? Small surface area will be rho d phi dz. Similarly here, sir, who is varying? Rho is varying. Sir, who is varying? Phi is varying. So what is the small distance? Rho d phi. So if I take this small portion, If I take this small portion, so what will be dA here? What will be dA? The dA will be nothing but rho d rho d phi. Right? Curvature distance would be rho d phi. Right? And this distance, radial distance will be d rho. Radial distance will be d rho. Curvature distance will be rho d phi. This is rho d phi and this is d rho. This is rho d phi and this is d rho. This is d rho. This is rho d phi. If you calculate this area, what area this will be? The area here will be rho d phi into d rho, or you can call it rho d rho d phi. Right? This will be the scenario. Understandable? Try making this one. Phi equals to pi by 3. Rho is varying from 0 to infinity and z is varying from 0 to infinity. Sorry, minus infinity to infinity. What you will be getting? You will be getting a surface area again. You will be getting a plate. X, Y, Z. Phi equals to pi by 3. This angle is fixed now. Nothing else is fixed. Z is also going from minus infinity to infinity and rho is also going from minus infinity to infinity. What does that mean? This angle is fixed, which is at pi by 3, and rest everything is varying. Basically, rho is going from 0 to infinity. Rho is always going from 0 to infinity. Rho is always going from 0 to infinity, and z is also going from 0 to infinity. So let's make in this manner: 0 to infinity, 0 to infinity, 0 to infinity. In that manner, it will keep on going. Okay, so this kind of plate you will be getting. I hope you are able to visualize. If you are not able to visualize, then also there is no need to worry. But this kind of plate will be there, and this angle will be nothing but pi by 3. So at the pi by 3 angle, let's just say there is xyz plane. At pi by 3 angle, you will be getting a plate. You will be getting a plate like this, right? In the radial distance, at an angle pi by 3, you will be getting a radial distance is going from here rho equals to 0, rho equals to 1, rho equals to 2, rho equals to 3 till infinity. This plate will be there till infinity. This plate will be there till infinity. All this plate will be there till infinity. Now on this plate, if I take a small portion, what will be the surface area? So you are moving a distance d rho in rho direction, you are moving a distance dz in z direction. So what will be the small area dA? That will be, you are moving d rho and dz. From here also you can check d rho we are moving and dz we are moving. So what will be the area? D rho dz. Understandable? Well and good. Crystal clear? Okay. Now we will study the spherical coordinate system after that, but let's solve one more problem. Rho is also varying, phi is also varying, z is also varying. What do you think what you will get? You will get a solid cylinder. Just think about it. Rho also varies. Just think about this structure. Here z was varying, phi was varying. Now rho is also varying. Rho is also going from 0 to 4. Rho is also varying from 0 to infinity. Rho is also varying from 0 to infinity. So isn't it covering the whole coordinate system? It is covering the whole coordinate system. It is covering the whole coordinate system. Whole coordinate system. Whole coordinate system. Whole coordinate system in cylindrical form. In cylindrical form. In cylindrical form. Say yes or no? Basically, I will just simply copy this diagram, or here also you can think. Now what will happen? Here z was fixed, no? Now z will also be varying. This circular plate, there was one circular plate, no? Which was for z equals to 3. Similarly, for z equals to 4, there will be one circular plate. For z equals to 5, there will be one circular plate. Z equals to 6, there will be one circular plate. Z equals to 7, there will be circular plate. So it will become a complete cylinder, right? And here what will happen? This angle is fixed. Here this angle is fixed. But now whatever this plate you are getting, along with the z axis you are getting this plane. Let's just say this is z axis. So this plate you are getting at a fixed angle, which is pi by 3. Now if I say that angle will vary from 0 to 2 pi, that means this plate will also move, no? This plate will completely move. This angle is varying from 0 to 2 pi. That means this plate will also move. As of now, the angle is pi by 3, which is fixed. Now, if I say the angle is moving from 0 to 2 pi, that means plate will also move. So again, it will make a cylinder, right? So what it will make? It will make the whole coordinate system in a cylindrical form. I hope you are able to understand this point. That's why it is known as cylindrical coordinate system. Is that clear to you or not? So yes, it will cover the whole coordinate system, all the coordinates of xyz plane. Sorry, not xyz plane, xyz coordinate system. It will take up all the points of the coordinate system. It will take up all the points of coordinate system, right? But in a cylindrical form. Here also you can assume that cylinder will be made. Here also you can visualize that cylinder will be made, and here also you can visualize that cylinder will be made. Is that clear to you? And small surface area you are able to take here, small surface area you are able to take here, small surface area you are able to take here. And what will be the complete volume? Complete volume is given by nothing but, sir, in the direction of rho we work for d rho. In the direction of phi, sir, we work for rho d phi. In the direction of z, sir, we work for dz. So what will be the volume? Rho d phi dz. There you go. Complete everything about your cylindrical coordinate system. You know everything. Say yes or no? Yes, sir. About cylindrical coordinate system, we know everything. Solve this question. X square plus y square equals to z, where z is going from 0 to 1. Is it a surface or a volume? Convert it into the cylindrical coordinate system. X square plus y square equals to z. Have we drawn it already? Yes, sir. In the multivariable function, you have shown us the graph. In the multivariable function, you have shown us the graph. Sir, the graph was made somewhat like this. First, x square plus y square equals to 0, then x square plus y square equals to 1 by 2, then x square plus y square equals to 1 by 3. In that manner, sir, circle will be made, and eventually, sir, we will get a bowl kind of structure. A bowl kind of structure. A bowl kind of structure. Eventually we will get a bowl kind of structure. So this will be a circle of z equals to 1. Here this radius will be 1. Basically this will be the circle of x square plus y square equals to 1. X square plus y square equals to 1. Inside that as well there will be some circles. Inside as well there will be some circles. Right? There will be circles and circles and circles. I hope you know how the structure would look like. These kind of circles would be there. What will be the equation of this circle? Let us say x square plus y square equals to 0.5. This will be the equation of the circle. Here what will be the equation of the circle? X square plus y square equals to 0. Right? So in that manner, circle, a lot of circles are there. First there was one circle, then another circle, another circle. So this surface we have made, no, this bowl kind of structure we have made. Like you can assume this globe from the upper side is open. Okay, so this only the outer surface we have made. Circle, 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 circle. So only the outer surface we have made. So is it a surface or a volume? If I talk about x square plus y square equals to z square, that means I am talking about this surface only. No, x square plus y square plus z. X square plus y square equals to z. X square plus y square equals to z. That means I am talking about this outer surface only. That means I am talking about this outer surface only. Right? I am only talking about this outer surface, which is x square plus y square equals to z. Right? Now if I need to convert, what I will do? I will take x equals to rho cos phi, y equals to rho sin phi, and keep z as it is. But let me know the limits. Limit of z I already know. Limit of z will be going from 0 to 1. Now if I need to cover the outer surface completely, so what will be the value of phi? Just stand at this point. If you need to cover this circle, this red color of circle that has been made here, if you need to cover this circle, how much angle you need to move? How much angle you need to move? Complete 2 pi angle I need to move from 0 to 2 pi. What will be the range of rho? That you need to let me know. What will be the range of rho? What will be the range of rho? Rho will be going from where to where? Rho is the radial distance from z axis. Rho is the radial distance from z axis. This is your z axis. From z axis, what is the radial distance? Let's just say you are standing at this point. You are standing at some point inside. I will have to erase some part. Okay, I will have to erase some part. This much part I am. You are standing at some point. Here, what is the value of rho? Here, the value of rho is 0. When you reach at the surface of this, when you reach at the surface of this bowl, when you reach at the surface of this bowl, when you reach at the surface of this bowl, what will be the value of rho you will be getting? If someone has said rho is from 0 to 1, then he is wrong. Rho is not from 0 to 1. Rho is going from here. Rho equals to 0. Rho equals to 0. Rho is going from rho is coming till the surface of the bowl. No. Here the value of rho is 1. I know. Rho is going from 0 to 1. But always rho is going from 0 to 1. No. Here rho is going from 0 to 0 only. From this point, rho is going from 0 to till this surface. Rho is going from 0 to till this surface. So rho is coming from 0 till the surface. So x equals to rho cos phi I have assumed, y equals to rho sin phi I have assumed. I have given you a trick. What did I say? X square plus y square equals to z. Always put here rho square. What is x? X is rho cos square phi. What is y? Rho square sin square phi equals to z. So what is the value of rho square you are getting? That is z. What is the value of rho you are getting? Under root z. That means rho is going from 0 till under root z. 0 till the surface. So rho is going from 0 till under root z. Say yes or no. Did you understand this point or not? From 0 to under root z it is going. Did you understand this point or not? I hope it is clear to you. Right? I hope it is understandable. I hope it is clear. Z is going from 0 to 1. Phi is going from 0 to 2 pi. Complete circle it is making. 0 to 2 pi, 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. Complete circle it is making. What about rho? Rho was complex. Just think about that bowl. Just think about this bowl. Just think about this bowl. From the z axis, radial distance. Rho equals to 0 to till the surface. Till the surface. So at the surface, what is the value of rho? At the surface, the value of rho is under root z, sir. From here we have understood. From here, from this scenario, sir, x square plus y square equals to z was given. Sir, x square plus y square equals to z. This is the equation of the surface. Sir, I need to find out at the surface what is the value of rho. At the surface, what is the value of rho? So, sir, at the surface, what is the value of rho? So, sir, rho square cos square phi plus rho square sin square phi equals to z. So, rho square equals to z. So, at the surface, value of rho is under root z. Right? So, have I written this correctly? That rho is going from 0 to under root z? No. Rho equals to under root z only. No, rho is not going from 0 to under root z. Basically, we are talking about only the surface. No, we are talking about only the surface. So, value of rho is nothing but under root z only. Here I should have written value of rho is nothing but under root z, because we are talking about the surface. Rho is fixed on this surface. No, on this surface rho is fixed, which is equals to under root z. Am I confusing you? I might have confused you here. I know that. First I wrote down rho is going from 0 to under root z, which was wrong, because we are not covering the volume here. We are covering only the surface area. Only the surface we are covering. So surface is simply on the surface. We only need to talk about on the surface. On the surface, what is the value of rho? On the surface, what is the value of rho? On the surface, the value of rho is nothing but under root z only. Only on the surface we are talking about. This is something we are talking about only on the surface, not about the volume, only about the surface. So for covering this surface, z should go from 0 to 1. Yes, sir. Value of z is going from 0 to 1. Phi is going from 0 to 2 pi. But rho is remaining constant on this surface, which is equals to under root z. Although z is also varying, that's why rho is also varying. because here the row value is from 0 to 0. Here the row value is 0 to under root z, 0 to under root z, 0 to under root z. But you are not talking about the volume inside. You are only talking about the surface. And on the surface, what is the value of rho? That is under root z only. So here I should have written rho equals to under root z, not from 0 to under root z. If I talk about 0 to under root z, that means I am talking about volume. Basically, if I write down z is going from 0 to 1, phi is going from 0 to 2 pi, and rho is going from 0 to under root z. That means I am talking about the volume. I have covered the whole volume. Why is that so? Because 0 to 1 in the z direction I have moved. 0 to 1 in the z direction I have moved. 0 to 2 pi, that means the complete angle I have moved. And along with that, from inside the bottle, from 0 to under root z, that means from inside of the bottle till the surface I have come. That means I have covered the whole volume. So this is the volume and this is the surface. I hope you are able to understand now. When we were talking about the surfaces, what was the scenario? Two things were varying and one was constant. Two things were varying, one was constant. Two things were varying, one was constant. Two were varying, one was constant. And when everyone was varying, that means we were making a volume. So if everyone varies, then we will make a volume. If two vary and one is constant, then we will make a surface. And if two things are constant and only one thing vary, then what do we make? We make a line. When only one thing vary, only phi is varying from 0 to 2 pi, when only phi is varying, we will end up making a line. Here, we ended up making a line. We ended up making a line because only z was varying, only rho was varying, only phi was varying. We ended up making a line. Here, two things were varying, so we ended up making a surface. And now, when three things were varying, we ended up making a volume. So similarly here, we are talking about a surface now, because x square plus y square equals to z is a surface, not a volume. We are talking about a surface. So here, what is the scenario? Z is varying from 0 to 1, phi is varying from 0 to 2 pi, and rho is equals to under root z. Rho on the surface is equals to under root z only. But if I talk about the volume, for the volume, z will vary from 0 to 1, rho will vary from 0 to 2 pi, and phi will vary from 0 to 2 pi, and rho will vary from 0 to under root z. Is that clear to you? Okay. So this was about cylindrical coordinate system. Next we are going to study about spherical coordinate system, but after a break. I will take a break, then I will come back and we will study about spherical coordinate system. Again you need to reach at the point P, but there will be different way of reaching at this point P. Okay. So we will study about that, but after a break. Yeah, welcome back. So we will study spherical coordinate system now, but before that, just to clear the confusion of this particular question, let me frame one more problem. Okay, what I'm going to do is that I'm going to simply copy the same page and I'm going to frame one more problem here. Okay, so I'm copying the same page here. Just 1 second, guys. Yeah, so it is copied, and now what I will do is that here I will put x square plus y square less than z, and z is going from 0 to 1. This was the question back then. X square plus y square equals to z, z is going from 0 to 1. Now x square plus y square less than z, z is going from 0 to 1. So is it a surface or a volume? Then convert it into the cylindrical coordinate system. This is what I am asking you. Okay. So now this is the question. So what will happen now? What kind of structure you will get? Sir, x square plus y square less than z if I need to make. So first what I will do, sir, first I will make the structure of x square plus y square equals to z. So sir, the structure of x square plus y square equals to z would be somewhat like this. This will be the structure. X square plus y square equals to z. This will be the structure of x square plus y square equals to z. It is a 3D bowl kind of structure that I already know. 3D bowl kind of structure, right? But sir, now what they are asking, and what will be this point? This point will be z equals to 1. This point will be z equals to 1. X equals to 0, y equals to 0, z equals to 1. But what they are asking this time, x square plus y square less than z. So either the region would be inside this bowl, right? Region would be either the inside this bowl or outside this bowl. So what I would do, I would pick up one point. Inside the bowl, I would pick up this point, 0, 0, 1 by 2. So if I put 0, 0, 1 by 2 here, what I will be getting? 0 less than 1 by 2. Is that correct? Yes, sir, it is correct. What does that mean? That means x square plus y square less than z will show all the region inside the bowl. That means it will show everything inside the bowl. Are you able to understand this point? So if I can fill the color, it will be a solid bowl this time. Are you able to understand this point? What I am saying? It will be a solid bowl. Previously, it was not a solid bowl. This time it will be a solid bowl. This was only a surface, but this time this will become a solid bowl. That means it is filled with something. X square plus y square less than z. If you are not able to understand in this manner, then what we can do, this is the one way of making the graph. What could be the other way? Other way would be that, sir, other way would be that what I need to make, x square plus y square less than z I need to make, no? And z is going from 0 to 1. So let's take values. First I will take z equals to 0. So I need to make x square plus y square less than 0. So x square plus y square less than 0 will be simply a dot only. Then let's take z equals to 0.5. So what I need to make, x square plus y square less than 0.5. So do you know how to make x square plus y square less than 0.5? Yes, sir. What I need to do is that first I need to make a circle of x square plus y square equals to 0.5. And less than 0.5, what does that mean? That means everything inside this will come. Everything inside this will come. Let's next take x square plus y square less than 0.75. What I need to do? I need to make a circle of x square plus y square equals to 0.75. Right? And then less than 0.75, that means everything inside this will be made. Similarly, here as well, x square plus y square less than 1. X square plus y square less than 1. That means I need to make a circle of x square plus y square equals to 1, and then everything inside will be taken. So similarly, there will be a lot of circles like that. Similarly, there will be a lot of circles like that, a lot of circles like that, a lot of circles like that, and all the circles will be piled up. All the circles will be piled up, right? All the circles will be piled up in this manner. If all of them will be piled up, then what you will get? You will get a 3D structure which is having a certain volume. Is that clear to you? So inside this there will be a certain volume, right? I hope you are able to understand that this will be covering a certain volume. So here what will be the limit? Limit of z. Z will be going from 0 to 1, right? What about phi? Phi will be going from 0 to 2 pi. Phi will be going from 0 to 2 pi. And what about rho now? Now rho will be going from 0 to under root z. Why is that so? Because we need to cover the entire volume now, no? We'll be starting from here. Rho will be coming from 0 to under root z. This is rho equals to 0 and this is rho equals to under root z. So rho will be coming from 0 to under root z this time. Rho will be coming from 0 to under root z, and it will represent a volume. 0 to under root z, and it will represent a volume, not a surface. Is that clear to you? Okay. So now whatever the confusion that I created here, I am sorry for that confusion. Whatever the confusion that I created, that I have cleared now. So here I don't need to write down this volume thing. This is the surface here. Here it was only the surface. So rho was fixed, which was equals to under root z. Rho was equals to under root z here. Z was varying from 0 to 1, phi was varying from 0 to 2 pi. This is the surface that we have made. Now when we talk about the volume, in the volume, rho is varying from 0 to under root z, z is varying from 0 to 1, and phi is varying from 0 to 2 pi. So this is the volume we are representing. This is the volume that we are representing. I hope it is completely understandable to you, right? Okay. And how will you convert x equals to rho cos theta? Sorry, x equals to rho cos phi, y equals to rho sin phi, and z equals to z only. Okay, so this is how I will be converting. Understandable? And this is how I will make the graph, which is completely clear to you. Next, spherical coordinate system. Again, you need to reach to the point P. What your friend said, you are at the origin. Your friend said, I am at this point. Your friend said that from the origin you cover the distance r. Your friend said, from the origin you cover the distance r and you will reach me. Is it enough? From the origin you cover the distance r. Is this information enough? You will say, from the origin I covered the distance r, I did not reach you. From the origin I covered the distance r, I did not reach you. From that origin I covered the distance r, I did not reach you. There will be a lot of points, right? So this information is not enough. Then he said, cover the distance r from the origin, making an angle of theta with z axis in the downward direction. Making an angle theta with z axis in the downward direction. This is your z axis, no? And this is your distance r. In the downward direction, look very closely. in the downward direction, not clockwise or anti-clockwise, in the downward direction, making an angle of theta with z-axis in the downward direction. So what you did, this was z-axis, this was the point P. You needed to reach here. What you did, you covered a distance r, making an angle of theta in the downward direction. You are supposed to reach at this point, but where you reached? At this point. But you followed the instruction. What he said, from the z-axis, from the origin, this is the origin, no, this is the origin. From the origin, you covered the distance r, making an angle of theta with z-axis in the downward direction. Yes, I made, but I reached at this point. He wanted me to reach at this point. Here as well the same coordinate is there. Distance is r, making an angle of theta with z-axis. Here also there is same coordinate. Distance r, making an angle of theta with z-axis. Here also there is same coordinate. Distance r, making an angle of theta with z-axis. Here also there is same coordinate. Distance r, making an angle of theta with z-axis. Here also there is same coordinate. Distance r, making an angle of theta with z-axis. So this coordinate is also not enough. Then what he said, whatever the r that you are making, no, take the projection of that r on xy plane. Take the projection of that r on xy plane. And this projection should make an angle of phi in the anti-clockwise direction with positive x-axis. Now this will be the correct coordinate. What he said, xyz plane, you need to reach at this point P. First he said only come for r, not enough, because from the origin covering distance r, there will be a lot of points. Then he said make an angle theta with z-axis. Make an angle theta with z-axis in the downward direction. Then also we got to know that there could be a lot of angles. This was my z-axis. Distance r, theta, distance r, theta, distance r, theta, distance r, theta. A lot of angles could be there. Right? After that what he said, whatever this r you are getting, no, take the projection of this r on zy plane. This is your zy plane, and this, sorry, not zy plane, this xy plane. Take the projection of this r on xy plane. Now this projection should make an angle of phi with x-axis. Now this will be the certain point only. Now this cannot be this point, because this will make a different angle. No, if you take a projection, this will make a different angle. This will make some different angle, right? So now this will be the certain point. This point will have the parameter of r comma theta comma phi. Now if this is r, then what will be the projection on z-axis? What will be this much distance? If this is r, this much distance would be what? This much distance would be nothing but r cos theta. This much distance would be nothing but r cos theta. What will be this distance? If this is r cos theta, just, are you able to visualize this plane? Are you able to visualize this plane? I am talking about this plane. Are you able to visualize this plane? This was a right angle triangle. If this is r, then here projection is r cos theta. What will be this projection? What will be this projection downward? This is again a right angle triangle. No, this angle is 90 degree only. Are you able to visualize this particular thing? This much length will become r sin theta. How much will be this length? This length will become r sin theta. This length will become r sin theta. Right? This length will become r sin theta. Now what do? Now we take the projection on x-axis as well, and we take the projection on y-axis as well. Basically on xy plane, if I just to show you xy plane, this is your y, this is your x, right? And one distance we have got, this distance we have got, which is r sin theta. This distance we have got, which is r sin theta. Making an angle of phi. This is x-axis, this is y-axis, right? So on x-axis, how much will be the projection, and on y-axis how much will be the projection. So on x-axis, sir, the projection will be, what will be this projection? Sir, this projection will be nothing but r sin theta cos phi. Say yes or no. R sin theta cos phi. And on y-axis, what will be the projection? R sin theta sin phi. And what is the projection on z-axis? That is r cos theta. So what is your x? X is r sin theta cos phi. What is your y? R sin theta sin phi. And what is your z? Z is r cos theta. And if you do square of all of them, x square plus y square plus z square, then you would realize that it is coming equals to r square only. Why is that so? Because what is r square sin square cos phi plus r square sin square phi? Basically r square sin square theta cos square phi plus cos square phi plus r square sin square theta sin square phi. What you will be getting? You can take r square sin square theta common, cos square phi plus sin square phi will become 1. So this is coming out to be sin r square sin square theta plus r square cos square theta. So take r square common, so sin square theta plus cos square theta will be 1. So what is the answer? R square only. So x square plus y square plus z square is giving you r square. X square plus y square plus z square is giving you r square. Right? And what is the value of phi? Phi is nothing but tan inverse y by x. If you just divide the equation, sin phi divided by cos phi, that is y by x. So phi is tan inverse y by x. Tan inverse y by x. Right? That is phi. And what about theta? What will be the value of theta? So theta will be cos inverse z by r. Cos inverse z by r. What is the value of r? Under root x square plus y square plus z square. So different values you can find out. You don't need to remember all these things, but you just need to remember what is x, what is y, what is z. Right? So visualization would be clear. No, then you will be able to write down very easily. Okay, sir. What we need to see is that, sir, we need to r distance from the origin. What is r? R is the distance from origin. What is theta? Theta is the angle made with positive z axis in the downward direction. And what is phi? Phi is the angle made by positive x-axis in the anti-clockwise direction with the projection of a position vector r. This is what is written. What is r? R is the distance of the point from the origin. What is theta? Theta is the angle made by the position vector with positive z-axis in the downward direction. What is phi? Phi is the angle made by projection of the position vector in xy plane with positive x-axis in anti-clockwise direction. This is your r comma theta comma phi. So if everything would be clear, no, then you will be able to take, sir, this is r, this angle is theta, so r cos theta will be my z. Now, sir, I need to find out x. So r sin theta cos phi, r sin theta sin phi will be my y, r sin theta cos phi will be my x. So if you just remember this diagram in your brain, no, then you will be able to write down x, y, z. Say yes or no. Is that clear to you? Okay, understandable. So here the coordinates will be r comma theta comma phi. Okay, so this is known as spherical coordinate system. Understandable? I hope it is completely clear to you that how will you reach to this point P, and the conversion are also clear. Now the important point is about the range. What will be the range of r? What will be the range of phi? What will be the range of theta? R is the distance. Range of r will be from 0 to infinity. That is completely clear to you. Range of r will be from 0 to infinity. 0 to infinity. What about the range of phi? Sir, phi complete path it needs to cover. So phi will be, sir, from 0 to 2 pi. 0 to 2 pi. What will be the range of theta? See the definition of theta very carefully and let me know what will be the range of theta. What will be the range of theta? Theta is the angle made by positive z-axis in the downward direction. This is your vector. This is your vector P. Here it will make some angle. Let's just say this angle is 45 degree. This is z-axis. This angle it is 45 degree. Then it will be making 90 degree angle. Then it will be making 135 degree angle. Then it is making 180 degree angle. If I make, let's just say from 180, let's just say I go to angle 225 degree. right? Are you able to understand this point? From where I started from here. This was 0 degree angle. This is my position vector, okay? And this is my z axis. Z axis position vector. Look at it very carefully. Z axis position vector. Understandable? What is the definition of theta? Just look at the definition of theta. What is the definition? Definition of theta is angle made by position vector with positive z axis in the downward direction. Listen to me very carefully. Angle is 45 degree. Angle became 90 degree. Angle became 135 degree. Angle became 180 degree. And when I reach here again, when I reach at this point, so someone would say that, sir, now the angle has become 215 degree. The angle has become 215 degree, sir. 215 degree. Right? It is greater than 180 degree. No. What is the definition? Definition says angle made by positive z axis in the downward direction. So now the angle is again this much, which is 135 degree again. Are you able to understand this point? Started from here. 45, 90, 135, 180. Fine. Just as I go above 180, what really happened? Just as I go above 180, people thought that it would be 215. But actually the definition says angle made by positive z axis in the downward direction. Anti-clockwise, clockwise I am not saying. In the downward direction. In the downward direction. So now in the downward direction, how much angle it is making? In the downward direction, it is making this 135 degree angle only. So started from here, which was 0, 0, 45, 90, 135, 180. After 180, I thought that it will go to 215, but actually in the downward direction, from this z axis in the downward direction, it is making 135 degree angle only. It is making only 135 degree angle here. Again, let me repeat. Started from here, 0 degree, 45, 90, 135, 180. Thought that it would make 215, but actually in the downward direction you need to take the angle. This angle came out to be only 135 degree. So theta is actually going from 0 to 180 degree only, not from 0 to 2 pi. Very, very, very important point. I hope it is clear to you. Say yes or no. It is clear or not. People just simply remember. They would simply remember. That's why if I need to cover the whole coordinate system, what I would do? Phi I would remember from 0 to 2 pi. R is going from 0 to infinity and theta is going from 0 to pi. This is something they would mug it up. But remember the definition. What is theta? Theta is the angle made by position vector with positive z axis in that downward direction. So 45, 90, 135, 180. After that 215, but in the downward direction, the angle actually became 135 degree only. Is that clear to you? So angle is actually going from 0 to 180 degree only. So theta would be from 0 to 180 degree, not from 0 to 360. No, from 0 to 180 degree. Is that clear to you? So this is how you will cover the whole coordinate system. Theta goes from 0 to 180, 0 to 180, 0 to 180. So basically it will be like this. That this is your z axis, no? This is your z axis. So it will be like this, that 0 to 180, 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 0 to 180. All are angle from 0 degree to 180 degree will be covered. 0 to 180, 0 to 180. Like this is the z axis, 0 to 180, 0 to 180, 0 to 180 in this direction, 0 to 180 in this direction, 0 to 180 in this direction. Then phi going from 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. Right? Phi is going from 0 to 2 pi, 0 to 2 pi, and r is going in the radial direction. R is radially covering all the distance. So r is radially covering all the distance. Here it is covering the distance. Here it is covering the circular distance, and then from the z direction downward distance, this theta is covering. So whole coordinate system is covered. In the circular manner it is covered. Is it clear? Okay. Let's mark up some point. Let's just say I need to mark a point of let's cover a distance of x equals to 2, y equals to minus 2, and x equals to 2, y equals to minus 2, and z equals to 3. X equals to 2, y equals to minus 2, and z equals to 3. Here we need to come. So how will I come? from the origin radial distance. What will be the value of this r? That you can find out very easily. The value of this r will be nothing but under root 2 square 4 plus 9, that will be 17, right? Making an angle of theta with positive z axis in the downward direction. Now the projection of this point, projection of this vector, what will be the projection of this vector? Projection of this vector will be this one. Projection of this vector, this is the projection of this vector. Projection of this vector. So let me make the projection in this manner. This will be the projection of this vector. So dotted it should be shown. This is the projection. So projection of this vector should make an angle of phi with positive x-axis in the anti-clockwise direction. This is the phi angle. Is that clear to you? Is that understandable to you? So phi, theta, all these values are not our matter of concern. It is just that this is how I can show it. Making an angle, this projection should make an angle with positive x-axis in the anti-clockwise direction. Phi angle it should make. Is that clear? So this is how I can show the coordinates. Theta value also I can find out, but let's not care about it. Understandable? Okay, well and good. What will be theta value? Theta value will be cos inverse z by r. What is the value of z? Z value is 3 divided by r, that is under root 17. Right? What will be the value of phi? For finding out the value of phi, what I will do, this much, how much is this distance? In the direction of y I am working 2. Here also I am working 2. So this angle will be 45 actually. This angle will be 45. So value of phi will be actually this 360 minus 45 degree. It would be 360 minus 45 degree. Okay, so it would be 315 degree. So value of phi will be 315 degree. Value of theta would be 3 by under root 17. So these are the values. Okay, so whatever the angle that you get, so that will be the coordinate r comma theta comma phi. So this will be the coordinate. Although no one will ask you to find out, or they can ask as well. Who knows, whatever can be asked in the examination. That just simply convert 2 comma minus 2 comma 3 in r comma theta comma phi. In spherical coordinate you convert. So our value of r will be under root 17. Theta value will be cos inverse under 3 by under root 17, and phi will be 315 degree. So all these things can also be asked. No one knows what could be asked in the examination. Okay, so this is also clear. The range of theta is also clear, and the conversion is also clear, right? Now let's move for a small distance. So small length in the direction of r, if I move, small length in the direction of r. This was your r. R was the radial distance from the origin. Radial distance from the origin. So you are at point r. You need to go to r plus dr, right? So how much will you work? You will work for dr, right? So you will reach at r plus dr. So moving for a small length in the direction of r is dr. Moving for a small length in the direction of theta, what that would be? So I am already at theta. This is what they are saying. I am already at theta. So this is your position vector. This is your position vector. This is known as position vector, which is already at theta. Making it has already made an angle of theta, and this distance, let's just say, is r. Now what you are doing? You are making an angle of theta plus d theta, but r is not changing. Now what you are doing is that you are making an angle of theta plus d theta, but r is not changing. So angle you are making now theta plus d theta, but this r is not changing. R remains the same. So you have moved from this point to this point, right? From which point to which point? You have moved from this point to this point. So from theta to d theta you have moved. So how much is this much arc length? This arc length is r d theta. So moving in the theta direction, it will be r d theta. How much will be moving in the direction of phi? Where is phi? Phi is there in xy plane, right? Where is phi? Phi is there in xy plane. You see the structure, phi is there in xy plane. So let's make the xy plane only. Let's make the xy plane only. This is your x, this is your y. In between there will be this length will be your, what is this length? This was your r, this was r cos theta, this is r sin theta. So this length is r sin theta. R sin theta, and you are already at angle theta only. Sorry, you are already at angle phi only. You are already at angle phi only. And the distance is r. What is this distance? This distance is r sin theta. Right? So from phi to you need to go to d phi. From phi to d phi you need to go. Phi to d phi. Phi to d phi you need to go. Phi to d phi you need to go. That means from this point to this point we need to go. So how much arc length you have covered? How much arc length you have covered? So r sin theta d phi. R sin theta d phi. This much arc length we have covered. Is that clear to you? On x-axis, look, this was your phi, right? This was your phi. In the phi direction, you have moved for d phi more. This much more you have moved. That means how much distance you have covered? R sin theta d phi, right? I hope you remember the formula of arc length. Arc length was, what was the arc length? Arc length was simply the radius multiplied with the angle. What is the radius this time? Radius this time is r sin theta. Here this used to be rho, right? Now rho has become r sin theta. So r sin theta d phi. So how much distance you have covered? You have covered the distance of r sin theta d phi. So working small length in the direction of phi is nothing but r sin theta d phi. Now for r theta plane, what will be the surface area? That will be r dr d theta. For theta phi plane, what will be the surface area? That will be r square sin theta d theta d phi. And for r phi plane, what will be the surface area? That will be r sin theta dr d phi, right? R sin theta dr d phi. For r theta plane it was r dr d theta. For theta phi plane it was r square sin theta d theta d phi, and for r phi plane it is r dr sin theta d phi. Understandable? This distance is clear, no? Sir, how we will be able to remember the distance? If you just remember this diagram, no, then all these distance are not very tough to remember. Just remember this diagram. Then all these distance will become very easy for you to remember. Distance r, this is the distance from origin. Just visualize in 3D. Distance from origin r. Then what is this angle? This angle is theta. So r cos theta will be z. Then r sin theta cos phi will be x. R sin theta sin phi will be y. Now I need to move for a small distance in r direction. In r direction I need to move for a small distance. That will be dr. In the direction of theta I need to move for a small distance. So this was my theta. So d theta I will move. So r d theta. So small distance will be r d theta. Now in the direction of phi I need to move. In the direction of phi I need to move. That means d phi I will move in the direction of phi. So r sin theta is already there. R sin theta d phi I will move. R sin theta d phi. R sin theta d phi. So it will not be very tough for you to remember. R sin theta d phi. Here the volume is very important. Very, very, very important. For spherical coordinate system, the volume is very important. What will be the volume? Simply multiplication of all these three. That will come out to be r square sin theta d theta, r square sin theta dr d theta d phi. So this volume is very, very, very important. Okay, this small volume, it is very important. All other things might not be used, but this volume will be used. R square sin theta dr d theta d phi. Is it tough to remember? No, sir. In the direction of r, how much you moved? Dr. In the direction of theta, how much you moved? Sir, d theta, r d theta. R d theta. In the direction of phi, how much you move? Sir, r was there. This angle was theta. So r sin theta d phi. On xy plane, it will be, projection will be r sin theta d phi. So this much we move. Simply multiplication of all of them. So simply multiplication of all of them will be r square sin theta dr d theta d phi. That's it. This will be the volume. So it is not very tough to write down. What was the volume of what was the volume of a cylindrical coordinate system? In cylindrical coordinate system, what was the volume? Okay, sir, in cylindrical coordinate system, we had rho, phi, z. How much do we move in the direction of rho? D rho. How much do we move in the direction of z? dz. How much do we move in the direction of phi? In the direction of phi, how much do we move? Rho d phi. So what was the volume? Rho d phi, rho d rho, d phi, dz. That's it. This was the volume. So very easy to remember. Just if you just revise this lecture one more time, no, then everything will become very easy. Otherwise, you will feel like that sir, coordinate system is very tough. Integral calculus is very tough. I will just solve some simple question in the lectures, and you will feel like that I know integral calculus. But when you go to PYQs, you will feel struggle there. Okay, right? That's why I am spending so much of time on the coordinate system, because if you understand the coordinate system in the best possible manner, then there is no one who can stop you in solving the toughest ever problems of integral calculus. Otherwise, you will be dropping some questions. You will feel that sir, they are out of the syllabus. This thing is there, that thing is there. It will be not asked, it will not be asked in my branch. It will be asked in other branch. All these regions you will start making. But we need to understand in a good manner, and we need to have the clear idea. Again and again I am repeating the same thing, so that you have the clear visualization in your mind. This was the diagram of spherical coordinate system. This was the diagram of a cylindrical coordinate system. It should be there in your mind. Sir, what was the cylindrical coordinate system? I need to reach at this point P. My friend said directly come to distance rho, making an angle of phi, then come to z. For spherical coordinate system, what he said, directly come here, but it was not enough. Directly come here, not enough. Make an angle of theta, then take the projection, which is rho only, making an angle of phi. So this much scenario is same here. Take the projection, which is rho only. Now what is the value of rho? Value of rho is r sine theta. That's it. Value of rho is r sine theta. Like here, what was the value of x? X was rho cos phi, no? X was rho cos phi. Now what is the value of, if I say this is r and this is theta, then what is the value of rho? Value of rho is nothing but r sine theta. So what it will become? R sine theta cos phi. Is it the value of x? Yes, it is the value of x only. You see, r sine theta cos phi. So all the coordinates are interrelated with each other. It is nothing. It is very simple aptitude, nothing else. It is nothing but simple aptitude only. If you look it very closely, it is nothing but simple aptitude. So distance of r, he said, but that was not enough. He said take the projection and make an angle of phi with the x-axis. So phi going from 0 to 2 pi, same phi going from 0 to 2 pi. R going from 0 to infinity, here rho going from 0 to infinity. Here z was the same, but here the things are different. Here another theta is also introduced. Right? So projections we need to take. On z-axis the projection became r cos theta. On x-axis, on xy plane the projection became r sin theta. Now on the xy plane the projection is r sin theta, but making an angle of phi. So on x-axis the projection will be r sin theta cos phi. On y-axis the projection will be r sin theta sin phi. All the projection I know. Now I can work for a small distance. In the direction of r it will be dr. In the direction of theta it will be r d theta. In the direction of phi it will be r sin theta d phi. Then I will be able to write down the small volume as well, which will be r square sin theta dr d theta d phi. R square sin theta dr d theta d phi. All these derivation also I have seen. Is that clear to you or not? I hope it is completely understandable. Okay. Let's draw the locus, but electricity is not there, so it is tough to record because there is no AC, there is no fan, so it is tough to record. But we will draw some locus only here now. Okay. Only some locuses we need to draw. R equals to 4, theta equals to pi by 3, phi is going from 0 to 2 pi, and 1, 2, 3, 4, 5, 6. These 6 locus we need to draw. After that, it will be completed. So you can try doing it on your own. Okay, 6 locus you need to draw. You can try drawing it on your own. I will start the recording once the electricity comes up. Okay, so let me pause the video, drink some water, and then we will start drawing the locus. Yeah, welcome back. So did you try drawing the locus? R equals to 4 and theta equals to pi by 3 is fixed. R equals to 4 and theta equals to pi by 3. R equals to 4, theta equals to pi by 3. Theta equals to pi by 3. Okay, and R is 4. R is 4. Right? And phi is varying from 0 to 2 pi. Phi is varying from 0 to 2 pi. That means the complete circle it will complete. Right? It will take the complete circle. Phi is varying from 0 to 2 pi, so it will take complete circle. Here phi is 0, making an angle with x-axis 0 degree angle, then from 0 to 2 pi it will make the complete circle. That's it. This will be the locus. Okay. So this line will be the locus. Now what will be a small portion on this line? What will be a small portion on this line? That will be nothing but what will be a small portion? You will let me know what will be the small portion. That small portion will be in the direction of phi. What will be that small portion? In the direction of phi, how much do you walk? You are only moving in the direction of phi, no? This is a line, right? You can call it circle or you can call it line as well, because it is not a surface. It is neither a volume, it is nor a surface, so it is a line only. So in the direction of phi, what is the small length? In the direction of phi, the small length is, sir, r was the distance, r sin theta d phi. So this small distance will be r sin theta d phi. Right? We have written it, no? In the direction of phi. In the direction of phi, r sin theta d phi. So here the small length will be r sin theta d phi. R sin theta d phi, and it will be a circle. So this will be the locus. Okay. What about the next one? R equals to 4, phi equals to pi by 3. R equals to 4, phi equals to pi by 3. So angle made with x-axis is pi by 3, which is fixed. And r is equals to 4. But theta is varying from 0 to pi. That means theta will completely vary like this. Okay. So this kind of structure only we will make. And r equals to 4 is also fixed. R equals to 4 is also fixed. When you take its projection on x-axis, when you take its projection on xy plane, then it will make an angle of pi by 3. This is also fixed, but theta will vary. Theta will vary. Theta will completely vary. What does that mean? That this theta will vary. This theta will vary completely from 0 to pi. Right? Theta will vary completely from 0 to pi. So this kind of line you will be getting. Theta varying from 0 to pi. This kind of line you will be getting. So if I take a small portion here, in the direction of theta, how much do you walk? In the direction of theta, r d theta. So this small portion will be nothing but r d theta. Right? So this will be the locus. Pi by 3 is fixed, r equals to 4 is fixed, but theta is varying. So this will be the locus. What about the next one? Theta equals to pi by 3 is fixed. Phi equals to pi by 6 is also fixed. Like basically now this time r is varying. R is going from 0 to infinity. So simply it will be a line. Simply the locus will be a line like this. It will be a line like this. It will be a line like this. This will be the locus. And this line will be making an angle of pi by 3 with z axis. Pi by 3 with z axis. And when I take its projection, when I take the projection of this line, it will make the angle of pi by 6 with x axis. This is the scenario, right? And if what will be the small portion on this line? The small portion will be nothing but dr. Very simple and very straightforward. What about this one now? Now only theta equals to pi by 3 is fixed. Theta equals to pi by 3 is fixed. R is also varying and phi is also varying. R and phi both are varying. Theta equals to pi by 3 is fixed. Let's just say r is 0, phi is 0. And theta equals to pi by 3. R is 0, phi is 0. R is 0, phi is 0 will be here. Let's just say r is 1 and phi is pi by 4. R is 1. R is 1. Let's just say r is 1. This is your r equals to 1. R is 1. And theta will take all the values from 0 to 2 pi. That means it will make a circle. Now let's just say r is 2. R is 2. Then theta will take all the values from 0 to 2 pi. R is 2. Theta is taking all the values from 0 to 2 pi. Let's just say r is 3. R is 3. And theta will take all the values from 0 to 2 pi. In that manner, it will keep on going. So what do you think what it will make? And similarly, like r is the radial distance, no? So it can be in any other direction as well. In this direction as well, r will be the radial distance. So what it will make? It will make a cone, right? It will make a cone. What it will make? It will make a cone. So it will be a cone-like of structure, but it will be spread till infinity. Spread till infinity. So it will make a cone, but spread till infinity. Till infinity it will be spread. Only what is fixed? Only theta equals to pi by 3 is fixed. That means angle made with positive x-axis, positive z-axis in the downward direction, that is pi by 3. Positive z-axis in the downward direction, which is pi by 3. Similarly, here also there will be surface. No, basically this will be a complete surface. Complete surface it would be. I hope you are able to understand. This will be a complete surface. It will be a complete surface. Complete surface like this. It is a complete surface like this. Right? It will be a complete surface. So this kind of conic structure would be there. This is a complete surface. Right? So everywhere the angle made with positive x-axis on this whole surface of the cone, in this whole surface, on this whole surface of the cone, on this whole surface of the cone, everywhere the angle will be nothing but pi by 3. Everywhere the angle will be made with positive z axis will be pi by 3. Angle will be pi by 3. Pi by 3, pi by 3 will be the angle. Right? So what will be the surface area? What will be a small surface area? So where you are moving? You are moving in the direction of phi, you are moving in the direction of r. So when you move in the direction of r, you work for dr distance. When you move in the direction of phi, you move for r sin theta d phi. So this will be the small portion which will be r sin theta dr d phi. That's it. Okay. So this will be the conic structure. Next, phi equals to pi by 3 is fixed. Theta is also varying and r is also varying. Phi equals to pi by 3 is fixed. Phi equals to pi by 3 is fixed. So whatever the vector that you will be getting, this angle pi by 3 is fixed. Now r will also vary. R will vary from, let's just say r equals to 1. Let's just say r equals to 1. R equals to 1. And theta will vary from 0 to pi. Theta will vary from 0 to pi. Then r equals to 2, theta will vary from 0 to pi. R equals to 3, theta will vary from 0 to pi. Basically, this is the scenario. No, r equals to 1, theta will vary from 0 to pi. So this complete structure you will be getting. Then r equals to 2, theta will vary from 0 to pi. Then r equals to 3, theta will vary from 0 to pi. So a circular disc are you getting? Are you able to understand this point? You will be getting a circular disc. R equals to 3, theta will vary from 0 to pi. And in the previous example as well, here also I did a mistake. Like I made only this much of portion. Like it will also be a circular disc. Like here, what is the scenario? R equals to 4 is fixed. And this is also fixed. No, phi equals to pi by 3 is also fixed. So yeah, this is fine. This is actually fine. This is actually fine. But here in this case, what is the scenario? That phi equals to pi by 3 is fixed. Phi equals to pi by 3 is fixed. Right? But theta will vary. Theta will vary from 0 to pi. Theta will vary from 0 to pi. And r will also vary. R will also keep on varying. Like this distance will keep on varying. This distance will keep on varying. So what do you think what you will be getting? I will be getting a disc only. I hope you will be able to understand this point. That I will be getting a disc which is spread till infinity. I will be getting a disc like this. A disc like this only, which is spread till infinity. Spread till infinity. Till infinity. Spread till infinity. The disc will be spread till infinity in this manner. Disc will be spread till infinity. Okay, from starting from here. When I am saying disc, that means I am talking about the surface. So it will be a surface. I hope you are able to understand. Here, what is the value of r? R equals to 1. Here, what is the value of r? R equals to 2. R equals to 3. R equals to 4. Then r equals to 5. R equals to 6. R equals to 7, and so on. Right? So this kind of disc you will be getting, which is spread till infinity. Now, if you take a small portion on this disc, what will be the area of that small portion? So in the direction of r, dr, in the direction of theta, r d theta. So what will be the small area? That will be r dr d theta. Next, r equals to 3, theta will vary, phi will vary. R is 3, which is fixed. Theta will go from 0 to pi, and phi will go from 0 to 2 pi. Theta will go from 0 to pi, phi will go from 0 to 2 pi. Theta will go from 0 to pi, phi will go from 0 to 2 pi. That means it will make a hollow sphere, right? It will be simply a hollow sphere. Only r is fixed, and rest all are varying. Phi is going from 0 to 2 pi. 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 Phi is going from 0 to 2 pi, right? And here this r is fixed. Everywhere the r is fixed. Value of r is 3. Value of r is fixed everywhere. The value of r is fixed everywhere. The value of r is fixed everywhere. The value of r is equals to 3. But phi is varying. Here you can see phi varies from 0 to 2 pi completely, right? 0 to 2 pi completely, and theta also varies from 0 to pi completely. So this will be a hollow sphere. Basically, it will be the surface of the sphere. Surface of the sphere. Hollow sphere means I am talking about the surface of the sphere. So what will be the surface of the sphere? If you take a small portion on the surface of the sphere, what that would be? If you take a small portion on the surface of the sphere. So who is fixed? Only r is fixed. If r is fixed, that means theta is varying and phi is varying. So if theta is varying, then r d theta, and if phi is varying, then r sin theta d phi. So what will be the surface area? That surface area would be r square sin theta d theta d phi, and this is also important. Okay, there you go. That's it. I hope you are able to understand these locus. Not very important, but yeah, if these kind of locus are given, then I would be like very comfortable. If they are talking about the surfaces, then I will be simply converting the coordinate system, and then I will be able to solve the problems in a very easy manner. Otherwise, if you solve the problem in x, y, z coordinates, no, then it will become very difficult. But when I convert it into spherical coordinate system or cylindrical coordinate system, then the problem will become very, very, very easy. The integration will also become very easy. So that's why we are studying the coordinate system here, and here your coordinate system is completed. Okay, so these locuses we need to see. Locuses are not very important. This is something that is important, that for a sphere, what is the surface? For a sphere, what is the surface? Sir, for a sphere, r is constant. If you talk about the surface of a sphere, no, like this is a sphere. If I am on the surface of this sphere, so here r is constant. No, everywhere r is 4, r is 3, r is constant. So if r is constant, what does that mean, sir? Theta is varying from 0 to pi. Theta is varying from 0 to pi, and phi is varying from 0 to pi. Phi is varying from 0 to 2 pi. Right? Okay. So if theta and phi both are varying, so what will be the surface area? The surface area will be, sir, r d theta multiply with r sin theta d phi. That means r square sin theta d theta d phi. So all these expression I will be using directly when I study integral calculus. Now integral calculus, after this lecture, spend 1 more hour. I would say spend 1 more hour on this lecture. Study it completely, whatever that I have taught, all the expressions and everything. Do you need to mug it up? No. All the expression you write down on your own, make the diagrams on your own, and you will be able to understand everything. And then after that you study vector calculus. After that you study vector calculus or integral calculus. Everything will be a cakewalk for you. Okay. So let's meet in the next lecture. In the next lecture, we are going to study those basics which we have already studied in class 11, 12th. Right? But after that, we will start double integration, triple integration, which are some new concepts. Although these concepts are also new, but these are like a prerequisite. Now next will be our single integration. So definite and indefinite integration we are going to see, which we have already studied in our class 11, 12th. So next lecture will be based on, mostly it will be based on whatever that we have studied in class 11, 12th, but some problem solving technique also we will see there. Some different problem solving technique also we will see, and some important results also we will see. Okay, so let's meet in the next lecture. Now this coordinate system is completed, which is very, very, very important topic. Okay, yeah, thank you very much. Happy learning.